So welcome everybody. I'm glad to see everybody coming in. I have to get with
rehearsal. Great. Hi, Mike.
How's it going?
How are you?
All's well, I think.
You look like you're in a sauna.
People tell me that this is my reading nook, so it's
it's very it looks cozy.
It's comfortable.
Fantastic. I'm just going to pop out and leave a message in the main event. Tell people that we'll get started here in just a few minutes. Give them a break for 5 minutes.
Yeah, absolutely. Plus,
I'll be right back.
Not one yet, so.
Okay, I'll be right back, Mike.
And of course, my clicker is not working now, even though I tested it 2 hours ago just to make sure.
Okay, so we're ready to at least welcome those who are listening. So I can tell by the technology that we have 29 people listening at the moment and 76 logged in. So
I'm going to need to get with Sean real quickly because there's a separate technology I use for sharing slides, correct?
You should be able to share slides directly from Hopin.
Oh, okay.
Yeah, if you look at the cog.
Yep. Okay, yeah, I've got it.
I often use slide sharing through Google Slides, and I use a separate tab, like a separate Chrome tab myself. But if you need any help, let me know. I can get Sean to pop on.
No, it's fine. I can use, if we're going to share through Hopin, then I'm good.
Cool. Let's do that. So those of us that can hear us, hopefully everyone was able to hear my introduction to Michael from the main stage. This is the Secure Operations Technology Workshop. It is the pre-conference workshop before the Control Systems Cybersecurity USA show. And Michael Furstenberg will be presenting for the next 4 hours until 5 p.m. Eastern Daylight Time. He's the Director of Industrial Security for Waterfall Security Solutions. And this course surveys industrial network security problems and introduces secure operations technology, a perspective methodology and set of best practices for designing secure industrial control systems. The world's most secure industrial sites generally deploy comprehensive IT-Sec programs as part of their OT-Sec posture. These sites also deploy a number of additional OT-centric mechanisms unique to operations networks. SecOT describes these additional mechanisms. So Michael will be elaborating further on that. That's just a little bit of an overview of what's coming up here in the next few minutes. It's about 5 minutes to go, and Michael will go ahead and launch us off.
So I am going to share my slides, but I'm not going to start yet because we want to be fair to those who are taking a break in between our two sessions today. We want to be fair to those who stepped out of the room, the virtual room, as it may be. So we don't want to start before our scheduled start time. I do plan to.
Sorry, we've had quite a few last-minute registrations as well, Mike. So just so you know, there's some water companies out there that are very keen on hearing what you have to say.
There's so much interest from the water companies. As an old water guy, I really do appreciate it. So I did promise to give some bio breaks. I won't go 4 hours straight. I'll make sure that we give everybody a moment to stand up, walk around, use whatever facilities are nearby for each individual.
Yeah, that'd be great. So we'll let you go ahead and do that. I know Eamon in the last workshop was trying to do it every 90 minutes, but do what works for you. Most of the attendees typically ask about recordings and PDF files and those types of things also. So I'll be here in the background, letting people on screen if they choose to wish to share video and audio in that manner. We do ask that folks do come on screen, really. It adds an interactive element to it and makes it all quite worthwhile, considering we can't get together face to face.
Agreed.
So don't be shy. I am broadcasting from the United Kingdom, and we have sun today. So,
very impressive.
We're celebrating. Where are you, Mike? Are you in Pennsylvania?
I'm in New Jersey today.
New Jersey.
I did catch one of the last flights back to the States from the UK before everything got shut down.
Yeah.
Here I am, and built myself a nice little reading nook because, pandemic, you got plenty of time. So I've got my nice bookshelf, and
good.
This is where I spend. When it's a typical English weather day, this is where I would be. If it's a nicer day, then I might be out. But
I hear you. One of these days, I'll get to Jersey.
Jersey or New Jersey?
Well, New Jersey. But I'm trying to be a local. Say, oh, Jersey, all the Jersey boys. But I've had a lot of friends from Boston, and that's about as close as I've gotten to Jersey. Other than visiting New York, but I've never been to New Jersey, never been to Boston. But I gotta get out there when all this is over.
Yeah, we'll entertain you. We've got food. So come for the cookies. Interestingly enough, at the Cyber Senate in London, the most recent in-person one in London, you said Jersey. I actually sat down with an engineer from Jersey Water, from the original Jersey, not the new Jersey.
Yes.
Yeah, that's why I had to ask.
Yeah, no, I don't blame you, because I was thinking, I should made a mistake there. But yeah, Jersey Water does attend quite a few of our shows, and
yep.
Yeah, just before lockdown.
Good group.
just before lockdown, we were lucky to run one of our Rail cybersecurity shows. It was in February of 2020. And everything was locked down about a month later, well, within weeks of that show.
Yes. Yep.
Okay, we have 1 minute to go. So, Mike, I'm going to go ahead and turn off my video and my microphone. I'm going to hand over this workshop opportunity, and thank you for your support. We really look forward to everything you have to say. And obviously, there's a chat mechanism here, and keep your eye on that for updates and questions from the audience. Thanks, Mike.
Very good. I'm going to have to flip back and forth between screens because I'm sharing my my slideshow, but my clicker broke, so I'm leaning forward and do it. We'll make the best of this situation, and if I don't see your input into the chat right away, I promise I will see it inside of a minute, 2 minutes on the outside if I'm still spouting off about something. So as we get started, as I do have 1300 on my watch now, we're here for Secure Operations Technology. That's SecOT for short. You already heard that's made the book, as you can. This is all based on a book. The book, as you can see, I did not write. It was written by Andrew Ginter. Andrew's a good guy. He's been around in this field for a long time. He and I go way back. I was an editor, the person who got all of the ideas in this book bounced off of me over the phone, back and forth. I was also a proofreader. The timing worked out that I could give some time to proofreading this book. So I'm not the author. I'm an editor for this book, but I was involved in it, and it's a great book. More on that later. So that's me. I think James already introduced me. So what all this adds up to is I used to do stuff, and now I talk about doing stuff. It's an entirely different world. It's contributing in a different way, and it has to be done. We can't all be the hands-on. We can't all be the design engineers. We need everybody's got to fill their role, and for now, this is my role. Recently, I joined the ICS JWG Industrial Steering Team, so that's a nice little cherry on top for me. I'm enjoying that role as well, and I hope that everybody's doing okay through the pandemic. I know it's been challenging for a great many of us. I've been very fortunate, and still looking forward to it being over soon and us getting back to whatever the new normal will be. At the bottom there is my email address. So one of the things I've learned over the decades is that people don't like to talk about their stuff in public. It's not, we'll talk more about it later. For now, I'll just say, if you don't want to talk about it in public, if you want to ask a question that's specific to your facility, to your plant, to your company, but you don't want to reveal anything about your company in public, that's my email address. If I respond, you'll have my phone numbers, or when I respond, I should say, you'll have my phone numbers. And then there'll be a way to have that conversation without the exposure that comes along with public putting stuff into the open source intelligence realm for everybody to discover. So real quickly, I'm not going to spend too much time on this. I work for Waterfall Security. Waterfall Security is a technology vendor. We've been around forever. Okay, not forever. We've been around about 15 years. I haven't been with Waterfall that whole time. I still tend to think like a customer, not think like a vendor. So you'll hear me use the word we when talking about water utilities. So I do apologize for that. The reason I bring this up is because it colors everything I'm going to say. We talk from experience. We all have our experience, and that guides our perspective, our personal experience, our professional experience. It guides our perspective. It guides everything that I'm going to say, because I can only talk to what I've experienced. I can't talk to other people's experience. It's not, that's an entirely different skill set. Even if I was talking to other people's experience, which I will be, I'll touch on it here and there. The fact is that my experience colors how I would interpret their experience. Keep that in mind as we're going forward. I will come back to that a couple times because I think it's an important note for everybody to remember who they're talking to and who they're talking with. Understanding that does always make a difference. Also, I have a pretty decent microphone. If my microphone is picking up my dog barking outside, which just happened, then I am sorry. Welcome to the pandemic. So let's start out with all that introduction behind us. Actually, before we start out into this, I probably should have had a little bit of logistics. Real quickly, we do intend to offer some breaks as need be, bio breaks. Make sure nobody is sitting around with being uncomfortable. I understand that people do need to get up and walk around. We used to do it back in the day. We called it manage by walking around, MBWA, because we couldn't sit still. But that's an entirely different problem, not the subject here. We will give breaks to make sure you get up and get the blood flowing, use your facilities, whatever needs, get a glass of water, whatever needs to be done. If you have questions, if you have any statements, use the chat or come on screen, and we'll get you. We'll get that going. We like the face-to-face. So if you're willing to put yourself on screen, then by all means, please do. And let's hope that this works. Yeah, the beauty of Bluetooth. Anyway, yeah, you guys can walk around. I have to be on camera. I don't get that beauty. Anyway, back to the presentation. So, this is what we're all here to talk about: industrial cybersecurity. It's the subject of the book, Secure Operations Technology. Or SecOT for short. I love the phrase OT. It's actually one of my least favorite acronyms in the entire world because I can, it's not very well known. Everybody knows what IT is. Not so many people know what OT is. Pre-pandemic, I remember serving. I was teaching a different class. Mainly engineers and operators, and I remember asking for a show of hands, who considered themselves OT, and nobody raised their hand, and somebody actually from the back of the room screamed out, "What is OT?" Everybody knows what IT is. Not everybody knows what OT is, even the people who work in it. It's a relatively new phrase in terms of in terms of the world. So it is operational technology. I felt the need that I have to introduce that because, once again, even that would be considered part of the OT team may not know what it is. All right, so industrial cybersecurity, SecOT. We're talking about physical processes. It's the process that we're here to protect. It's a very different type of cybersecurity than IT security, information security, the data security that is becoming a pretty mature field at this point in time. It's a well-regarded science. It's still completely understaffed, but that's a topic for another time. I apologize. I get sidetracked. I have tangential conversations oftentimes with myself, and you're going to hear me go down the rabbit hole of a story that'll take me a couple minutes, and then eventually I'll get back to what we're here to talk about. But I assure you, the tangents, the stories, they're all going to be related to the topic at hand. So physical processes. This is a plant. This is a large plant. Not going to say whose, but that's an actual overhead picture taken out of a helicopter on the way in. And that's what we're here to protect. We're not protecting the data, we're protecting the plant, the process. So what does that mean? Well, in data security and information security, we're protecting the CIA, the confidentiality, the integrity, the availability of the data. We're protecting the CIA of the data. It's different when we're protecting a physical process, where we have to think about what is the goal. That's the goal for data protection. For process protection, we're here to protect safety. Safety is always the first thing that we deal with in any plant. Before it goes live, there's going to be safety studies. There's going to be HAZOPs. There's going to be process hazard analysis. There's going to be all the safety checks that would go along with any site acceptance testing. That's always the goal. That's number one, and that's globally with very few exceptions. The fact is, if it's not safe, it's going to get shut down. If it's not running, it's not making money, and then we've got a problem. Safety is job one. It starts off every day with a safety minute. A lot of our conferences in our field start off with a safety minute, even though we're not in the plant, even though we're not in a company facility. We're sitting in a hotel ballroom, and we're still starting out with a safety minute. That's the culture that we're dealing with, and that's the goal of the cybersecurity program. But it's not the only goal. Reliability is significant. Much as if we're not safe, we're not running, and we've got to shut down. If we're not reliable, if we're not continuous and correct control, then we've got to shut down as well. If we can't see what we're controlling, in many jurisdictions, the regulations say you have to shut down if you can't see your process, if you can't monitor your process for X seconds or Y minutes, you have to shut down. It's because if you can't see it, you can't operate it safely. The reliability also means that we're doing it efficiently. Efficiently means we're able to make money. Once again, if we're not able to make money, the plant gets shut down, and then we don't have a security problem because there's no process running for us to protect. Last but not least in our goals is we've got to make sure that we are protecting the actual physical assets. Back in 2007, there was a project known as Aurora that was executed by the Department of Energy at the Idaho National Labs in the United States. Anybody who's been around in this field for any length of time has seen the video of the generator jumping around and smoking and effectively going boom in the night, except that it was during the day. The important part of this was not what the attack was. The important part was not if the attack was viable. The important part was not that particular generator. Project Aurora existed for one reason: prove that you can do physical damage to a big, expensive asset using nothing more than a cyber attack. And it did. Absolutely 100% successful. Generator destroyed, only cyber attack used. That's what we're here to protect. These things, you can't, once again, we're different than the IT side of the house, because if a switch dies, we can call our favorite vendor and have a new one there, sometimes within hours, if not within a day. When a transformer dies, when a generator dies, when a turbine dies, we don't get to restore from backup like we do with the database. We can't have a new one overnighted to us. We're down, and we're down for months, and that's the problem. That's how this is different. So we've got a little bit of background on cybersecurity. Let's start talking about what it is we're protecting. This is the visible part. This is what everybody sees. When you're watching your favorite television show or movie, this is the part that gets focused on. This is the HMI, the human machine interface. It had other names in the past, but long story short, this is the screen. This is what the operator sees. There's many different flavors of HMI. This is an actual control room, and it is, you'll typically have two operators sitting at this control room because it is a large system. Some smaller systems may only have one operator. Others may have a lot more, 10, 20, even more. Depends on the system, depends on it. There's a lot of it depends. That's probably the answer I'll give to most of the time when I'm asked a question is it depends. Might be, I don't know, that's also up there, but it's usually it's going to be it depends, because there is no one size fits all here. Back to the HMI. This is what people see. This is the control. This is the control room. This is how the operator controls the process. We talked about what we're here to secure. We're securing a physical process. We're securing a water treatment process. We're securing power gen. We're securing rail transport. Whatever it is, that's the process we're securing. The HMI is how the operator can visualize what's going on in the process. The process is not constant. The process is oftentimes going to, if it was put in an input, and you get this output, and it's going to be the same thing every time, well, we wouldn't need it. Not only wouldn't we need a cybersecurity program, we wouldn't need an HMI, because if it was that deterministic, it'd be done. But the world doesn't work that way. There's always going to be variables, and that's why we have our HMI. The HMI, however, is not the process. It's it's a tool. It's a tool that merits protection, and we do have to make sure that we're giving it the appropriate levels of protection, but it is not the process. Nothing will get you kicked out of a meeting quite as quickly as coming in and saying, I'm here to secure the HMI. All right, I'm done. We're secure. I put on the antivirus. I'm going home. There's a lot wrong with that statement. But the point I was trying to make with it is that the process folks know the HMI is just a visual indicator of the process. It's not the process itself. If you come in talking about the HMI is the only thing we need to secure because it's what people see, it's what people know about, well, you have no credibility, and then you're going home, and you may have to find something else to do. So it's not the best choice in terms of what we can do. So what are they controlling? That's a good question. So controllers and sensors, that's what runs our process. The controllers control, the sensors sense. Obvious? Yeah, good, we're done, everybody go home. Now, controllers. Controllers come in many flavors. Typically you'll hear PLCs, programmable logic controllers, RTUs, remote telemetry units. You rarely hear intelligent electronic device anymore because IED came to mean something else over the last couple years here, the last couple decades, I guess. So you won't hear any controller. You won't often hear people refer to a controller as an IED, but you might. If you do hear, if you're wandering through the plant and you hear somebody talk about the IED over there, it's not time to take cover. They're just probably lacking hair like I am. Anyway, so what are these things? They're computers. That's effectively what they are. They've got a processor, they've got inputs, they've got outputs. They are the actual control for the process. This is what's going to take information from the sensors and relay control to the actuators, things that move, things that change, and relay all of that information back to the HMI so that us humans at the human-machine interface can actually operate and take information in and make informed decisions of what we might need to change in our variables. Not going to go into control variables and process variables, and that's a different class for a different time. So that's the controller side of the house. Then we can go over to the sensor side of the house. What is a sensor? Well, it does exactly what you think it does. It senses. It senses, generally speaking, a very limited number of things. Temperature, yeah, we can sense temperature. Pressure, yeah, we can sense pressure. Okay. Level, yes, we can sense level. On, off, yeah, we can sense on or off. Flow, not really, to be honest. Yeah, there are flow sensors. You couldn't have a water meter if you didn't have a flow sensor, but oftentimes, most of the time, they're going to be based on either differential pressure or mass or level. So I won't get into that. That's going down the engineering rabbit hole, which I promised I wouldn't do. So these are the things we can measure. Why do we measure them? We measure them to make sure that what our output of our facility is, whatever that output is supposed to be, is coming out, quality. That's quality control. It's governing the process. It is exactly what it sounds like. We sense, we control, we make appropriate changes using the controllers from the HMI. A person sitting at an HMI makes a change based on the feedback from the sensors. That's the process. Of course, there's a physical component to it. Of course, we need that person to be safe. We need to make sure that everybody who's at the facility is safe. We need to make sure that the output of the facility is safe for the customers, safe for the environment, and so on. And that's what we're here to protect from a cybersecurity perspective. All right. So, yeah, a little more background, because all of this background comes into play. Just like the comic book movies, you'll get a backstory for every superhero and villain, anti-hero, whatever we're going with these days. I don't know. We need the background too. We need the backstory. If we don't have the backstory, we're going to have a problem, because we're going to go down the wrong road. We're going to waste our cycles. We're going to waste our time. We're going to waste our resources, our money, and we're not going to establish the proper level of goodwill that we need as cybersecurity professionals, working with our process friends, with our engineering friends, with our operations friends. And all of this comes under operational technology, production, maintenance, engineering, and so on. These are our friends that we want to make sure we're in line with. And one of the things you're going to hear a lot about is the Purdue model. Some people refer to it as ISA SP 99. That is not correct. ISA SP 99, also known as IEC 62443, is a cybersecurity paper, a bunch of papers, to be honest, totaling a little over 1,200 pages, geared towards cybersecurity for industrial automation and control systems. That's ISA SP 99. Purdue model is a functional model for process control. It's more in line with ISA SP 95, which is something else you may hear thrown around, but it's not equivalent. People will talk about these things being equivalent all the time. Not necessarily the case. In fact, it's not the case. I will caution everybody here that you're going to hear a lot of people talk about the Purdue model as a security reference. It is not. It is 100% not. For starters, the Purdue model was an academic creation, in collaboration with industry that was started back in 1991, 92, and you can draw your own conclusion as to how much cybersecurity content was going into this model at the time. It is better known in the engineering community as the Purdue Enterprise Reference Architecture. Nobody ever abbreviates it PERA. I know we love our acronyms. I'm no different. I'm lazy. I don't want to say Purdue Enterprise Reference Architecture. I'd much rather say PERA. But that's not what it is. So, once again, we got to establish the fact that we do understand. We are here to communicate, and we do understand what the goals of our cybersecurity program need to be. So real quickly, because the Purdue model is a functional model and not a security model, I'm not going to spend too much time on it. However, there is a large portion, in fact, the majority of the cybersecurity world believes that this is, in fact, a cybersecurity model. Therefore, we've got no choice but to be ready and willing and able to talk about it as such. So it's levels. It's level 0, 1, 2, 3, 4. Some say it's based upon timing. At level 0, you've got to respond to within milliseconds. Level 1, seconds. Level 2, minutes, and so on up the chain until you get to days. And that's an excellent way of thinking about this reference architecture. When you combine thinking about SP99, IEC 62443, with ISA 95, with the Purdue reference architecture, you can effectively come to a place where you're putting together a hierarchical model, and it'll look something like the graphic on this page. And once again, if you look at the 62443 model, it's zones and conduits. You can translate that to this type of diagram. Mind you, the Purdue reference architecture is over 600 pages in itself. Boiling it down to half a page diagram is just incredibly wrong on a number of different levels, and quite frankly insulting to those who worked on it. But if you did, and I apologize for my lack of a sense of humor, but things like that are really funny to me. If you did, this is what it would look like, and zones and conduits in between these bubbles. So I hope that is useful to everybody as we go forward. So what are we talking about here? Data versus monitoring versus control. This is what we started out with. This is the overall basis of what we're talking about. That's why I started out saying it's not about CIA or IT data. That's not what we're protecting. It's also not AIC, because CIA refers to the data, confidentiality of the data, availability of the data, and all important stuff. Noble pursuit, excellent career. I have the utmost respect for IT security professionals. I really do. They do a job that's very important in the world. I even tried to do it for 18 months. I have no passion for it, so I came back to the control system world. But I believe that they are doing great work. However, it doesn't translate, is what we're talking about here. When we're talking about a valve, like I said earlier, we can't restore a valve from backup. It's a different world. We can't protect the confidentiality of the level of water in our finished storage tank. These are not going to happen. You'll hear talk from a lot of people talk about how it's all data, and yeah, well, a lot of it is. And a lot of it's actual physical equipment and physical process and real materials. The chlorine that we're using to treat and disinfect water to remove some harmful things from the water before it goes out to all of us to become drinking water. Yeah, that is not data. In fact, if that gets released in a nice fiery cloud, because chlorine, extremely flammable. That's bad for the people at the plant. It's bad for the local environment. It's bad for the people who are nearby. It's not data anymore. I really don't want to minimize the the point here. Data security, IT security, noble pursuit. Great job. Those people who do that are fantastic. I don't have a bad thing to say about most of them. When you try to say that it applies to a plant, when you try to say it applies to industrial automation, that's where we're going to have an argument. So that's where we get started. Secure operations technology. This is what we're here to talk about. Fundamental laws associated with secure operations technology. Nothing is secure. I'm going to come back to that one because I love that. I love this. It's you know what? I'm just going to go with it. Nothing is secure. But you know, when you think about the definition of secure, you know, can we actually secure the process? Can we actually secure the data? Can we secure the application? Can we secure the operating system? I would claim that security is being misused as a word. Nothing is secure. You cannot be secure. It's just wrong to say that you can. It's marketing to say, yeah, you can be secure, or buy my secure stuff, or buy my stuff that'll make you secure. That's marketing. You can be more secure than you are today. You can be less secure than you are today. Can you be secure? No. It's not an achievable statement. When you look at the concept of what is secure, that's not a possibility. Plain and simple. So keep that in mind in conjunction with the fact that, as you're talking to people, just remember, number one, can't be secured. Number two, everybody's statements, everybody's projections, what everybody's going to say is based on their reality, which comes from our professional experience and our personal experience. So there's the warning. Hopefully everybody's taking that to heart because, well, you'll see later. Anyway, second fundamental law of cybersecurity. Yes, I still have a landline. I'm that old. Second fundamental law of cybersecurity for industrial facilities: all software can be hacked. This isn't just for our facilities. This isn't just for process engineering. This isn't just for industrial cybersecurity. This is globally. All software can be hacked. Software is written by human beings. You, me. Okay, I haven't written any software since 1992, and even then it was just a college project. But people do write software, and all of it is written by people, and people make mistakes. Some of those mistakes are always going to leave security holes in the software. Therefore, it follows that all software can be hacked. People make mistakes. It's going to happen. Next thing, it may be a little bit more juicy to dig into, and that's that all cyber attacks are, in fact, information. And because of that, every bit of information could, in fact, be an attack. So, fundamentally, a cyber attack, it's going to be data. That was the whole point of the Aurora project 14 years ago. Can I do something on my computer that will make that physical asset over there go boom? The answer is yes, of course. We know that now. But the key takeaway here is that that's what we're worried about. That's the concept that we're worried about. Data affecting the physical process in a negative way. So armed with that, we also have to be wary that any bit of information could in fact be that cyber attack. Now that's the fundamental problem here, is that how do we get the good from the bad? So, and does it really matter? Yeah, it matters. What are we seeing today? Permissions. We're not seeing a whole lot of those all software is vulnerable type attacks anymore. We're not seeing the 4 operating system 0-day attacks built into go after these 4 OS vulnerabilities just so that we can gain access. That's not something we really see today. You look at the attacks that have made the news, and I'm going to go to Oldsmar, Florida, for a number of reasons, but let's look at it. What happened? Was that a cyber attack? Sure, absolutely, that was a cyber attack. What vulnerability did it take advantage of? Anybody? Yeah, we don't know. Did it even take advantage of a vulnerability? Don't know. It may not have, is the answer. The issue with the Oldsmar attack was that the systems were exposed directly to a public network through a firewall, but still directly to a public network. They're connected to the internet at that point. That's the exposure that is the problem. Was vulnerability exploited? Who knows? We may never know. Attribution is really, really hard. Let's face facts. Maybe the cloud-based solution that was used for the remote access, maybe that had a vulnerability that was exploited by the attacker. That time will tell, or maybe not. Don't hold your breath waiting for the answers to come out, because they may never come. The point is, this attack used the existing software the way it was supposed to be used. A remote person logged into the remote access software and took control of the HMI over this remote access software and made a change to one of the variables. In that particular case, to how much lye was being added to the water. And yeah, that's an attack. Why is it an attack? Because it was over the internet? No. Because the lye was changed? No. Because none of that makes it an attack. In fact, had the exact same thing happened, but the person who performed the action was a supervisor who couldn't make it in that day for whatever reason, well, that's now known as E&O, errors and omissions. That's an error. But because we don't know who did this, it's now an attack. That's what we're looking at today. This is the type of attack that we should be concerned about. Why, if I'm an attacker, why am I going to waste my time searching for vulnerabilities, trying desperately to find a vulnerability in your operating system, in your software, in your firewall OS, in your firmware? I'm going to search all over trying to figure all this out. Why would I do that? That sounds hard. I'm lazy. I'm going to just use your systems. Oh, by the way, that ain't new. That is, basically exactly what happened in the Ukraine, back in 2015. For those not familiar with the attack in the Ukraine, December 23rd, 2015. Yeah, lovely timing, wasn't it? Remote attackers came in through the remote access system into the control system and effective for transmission utilities, transmission and distribution, power grid in the Ukraine. And not only did they turn off the flow of electricity, they also so that is using the systems against. They also paired that with a destructive attack where they, issued new firmware with some extra bits to effectively brick some PLCs out in the field. Long story short, lights went out. Lights were out for a while. Manual operations for, depending on who you believe, whose report you believe. I believe the engineer from one of the transmission companies that I spoke with, 10 months of operating manually. That's a problem. That's the cyber attack we're here to prevent, and that's what's actually being used. Is the permissions. They're not looking for vulnerabilities. They're using our systems against us. Maybe we'll come back to that later because there's a lot to unpack in the whole Ukraine thing. From the fact that the attackers were in the system for 9 months leading up to the attack. We'll come back to that one later. So, all right. So who are these attackers that we keep talking about? And why is all this relevant? Well, I'm sure the threat intelligence people, threat intelligence vendors who are on the call or will be exhibiting at the full event over the next couple of days, and they're going to be real happy to tell you that you need to know your adversary. And it's true to a certain extent. You saw on my profile that I coach youth soccer, and depending on what country you're in, I'm a youth football manager. So, yeah, I design offense, I design defense, I design the overall system, but I also need to know, if I know what offense is coming at me, I can defend against it. I can set up my defense to defend against it. And that's where threat intelligence plays in. It is relevant. I may need to reallocate resources. I may need to get new resources in order to build that proper defense, knowing from the threat intelligence what is going to attack me and how they're going to attack me. But it gives me a significant advantage if I know how I'm going to be attacked. It's not just in sports, and it's most definitely in cybersecurity as well. So who are these people, and why is one particular group left off of this list? So if anybody wants to put the group that I'm thinking about into the chat window, please do. We'll see who gets closest. So this is going up the chain from least sophisticated to most sophisticated in terms of the attacks that we're going to see. Who are these threats? What do we need to be worried about? Corporate insiders, we've always got that problem. We're going to have that problem. Personnel surety programs are huge. We'll talk more about that later. Organized crime is an interesting group just because it's exploded. Not literally, because that's what we're defending against. But once again, bad sense of humor. Organized crime is enormous and has been for about 2.5 years now. Ransomware, it almost always traces back to organized crime. It's a money-making activity. It's easy. It's deliberate, And it just makes sense because there's minimal investment and significant return. Of course, organized crime is going to get into this. That's what that's their MO. They're here to make money. Of course, we have our disgruntled insiders. That's a little harder to protect against. Hacktivists, whether you're in power and somebody has taken offense to the fact that you're operating some sort of dirty natural fuel into, or you've got nuclear and the nuclear is bad, or you come from water and wastewater and water should be free. It's a natural resource. And yeah, water can be free if you want it treated and delivered to your house on demand. Water companies might charge you for that. Anyway, but hacktivists are an actual real threat. These are the actors that they have an axe to grind. They've got a problem, a fundamental problem with what you do, with what we do, with what your plant does, with what that plant does. And they're true believers. They believe, they care immensely, and they're going to find a way. They've got time, and they're going to find each other and work together, and that's when it becomes really, really dangerous. And then, of course, the top two is what everybody wants to talk about: intelligence agencies and military-grade attacks. And there's a couple of fundamental problems when we start talking about this. The first is that, yes, there are advanced military-grade intelligence agency attacks out there. And yes, they will be used by organized crime in 2 to 3 years, because that's just the way it works. They're going to get out there, they're going to be used, or they're going to be released. And then once people have access to them, they're going to start using them to make money. What's the difference between military grade versus intelligence agency? Typically not much from a cyber perspective. The way I've always made the distinction is that military is going to include a physical component. Intelligence agencies, they're not coming on your soil. They're not coming into your plant. Nobody is physically going to be in your parking lot, etc. Down the road. Military grade, there might be a person physically in your facility. That's the difference, is physical access, unauthorized physical access. Other people will make the distinction elsewhere, but so what's missing? What's missing is the script kiddie. Script kiddies are still out there. Kiddie doesn't imply that it's my 12-year-old sitting downstairs at his desk, downloading Metasploit and having at the world. Script kiddie is a different term. It's basically for anybody who's new to the cybersecurity game from an attacker perspective. And yeah, that is what they're going to do. Metasploit, GitHub. They're going to unleash some, well-known attacks of yesteryear, probably indiscriminately, probably for no reason at all, or no reason that we can figure out as the defenders. But they do exist. And oh yeah, sometimes they hit. Sometimes they do actually hit. They don't have to leverage the work that others have done with Project Shine. Thank you, Bob and Jake. We don't have to. They may or may not even be aware of Shodan and going in to, effectively search the internet for publicly facing critical infrastructure. Or maybe they are, and that's what they're using to figure out what they're going to put their attack that they just downloaded against. And yeah, it does have an effect. It does have it hits, and if you're not protected against it, if you are exposed and the threat crosses the vulnerability, more on that later, it's going to be bad. And it doesn't matter that they were a script kiddie and not the NSA. It's still bad. They've still just created a problem for you in your facility. What does all this mean from a defense in-depth perspective? For starters, I don't like the phrase defense in depth. And yeah, it's, I had and this was explained to me at a government meeting a couple of years back. Defense in depth is a military term. Defense in depth explains how the momentum of an attacker degrades over time and distance. Okay, what does that mean in an IT perspective? Well, it sure doesn't mean give me some of this, some of that, and that. No, that's defense in breadth. It's my own problem. I recognize that. I'm the only one who's ever going to say it. I don't expect defense in breadth to ever catch on, but I have to say it because defense in depth is not actually what we're doing. We're doing defense in breadth. So what is it that we're actually doing? Well, we start with looking at what we're supposed to be protecting against. Because of our background, a lot of practitioners in the control system security realm came from the IT security realm. There is a tendency to go after the high frequency, low impact attacks. The stuff that's happening all day, every day, configure, still on millions of devices globally. Just about every ATM in the world has configure on it, in case you didn't know. So we got to block that. That happens all the time, every day. How do we block that? We get our firewalls, we get our antivirus, and we patch, make sure that we have MS, what was it, 0468 was configure? I don't even remember anymore. That was 17 years ago. I only had one kid. So it's a different perspective. What else can we add to all of this? Intrusion detection. Yeah, we could do that. And this is where I wanted to go back to the Ukraine incident. They had intrusion detection systems. Intrusion detection systems require an intrusion analyst. Yes, today we have machine learning IDS, we have AI IDS, we have AI ML IDS, EIO IDS. We have a lot. And on day 2 of every intrusion detection class, you learn evasion techniques. Do we think evasion techniques don't evolve along with the technology? Of course they do. We can't assume that the government, the intelligence agencies are saying, oh, well, they got ML, they got machine learning IDS, we're done. Pack up shop, where everybody go home. How about the organized crime? Are they saying, oh, they got artificial intelligence, we'll never get another dime out of this ransomware stuff. Pack it up. Let's go back to protecting windows in the street. Actual physical windows, not Microsoft. Sorry. I promise I'll stop at some point. But anyway, back to this. So the fact is, evasion techniques continue to grow just as IDS technology grows, and that's why eyes on glass. That's why it's not a perfect solution. That's why we can't make the assumption that we're going to find them before they can do something damaging. We can be hopeful. I'm not saying don't watch. That's irresponsible. Of course you need IDS. Of course, you wouldn't put a fence around your plant and not put a camera up to see what's going on. Of course, that's the physical equivalent. And it's irresponsible not to do that. It's similarly irresponsible to not have IDS when it comes to cybersecurity. If there were a breach, you wouldn't, and you did not have IDS, you would not be able to demonstrate a standard of due care that would relieve you of culpability here. That said, it doesn't stop the fact that you've been breached and you've got real problems, but that's a story that'll come up later. And once again, I talked about can't restore the turbine from backup, can't restore the person from backup either. If that chlorine gets released, let's say you had a control room where you're replacing the keyboard on that HMI every third month because the chlorine is rusting it. Do we really want a human in that control room breathing that air, breathing that chlorine in? I think we got to consider this, and we need our OSHA folks to weigh in on that topic before we can really go forward here. So, all of this said, this is still where we've got to be in terms of defense and breadth. Once again, you can call it defense and depth. I'm not asking anybody to change because nobody else in the world except for me will ever know what you meant unless you happen to be talking to one of the people who's on this today. So don't ever say defense and breadth when you're talking to people out there in the world. They won't know what it means. It's defense and depth. So we made it. We're here to talk about secure operations technology. We got the background out of the way. And it only took us an hour. Not too bad. I'll try to get less stories and less really, really fundamentally bad jokes in there. So this is exactly what we're here for. Same concept we've been talking about background-wise for an hour. We talked about IT security, information security, protect the CIA of the information. If you're older, it's, protect, it used to be DAD, destruction, alteration, or disclosure. That was a very negative message. So now it's positive. Protect the confidentiality, integrity, and availability. We're not trying to save the data from destruction. But security for operational technology is different. We're actually protecting the process from the information. We're not here to protect the information. We have people who do that. IT security people do that. Information security people do that, and they do it well. We don't need to do it. We need to protect our process from that information. So a quick word about this book that forms the basis of what we're talking about. You may have seen some reviews out there talking about this being controversial because of this reason or that reason. And the reality is this is reporting. This is Andrew's way of reporting. Andrew's been to a lot of industrial facilities. I've been to a lot of industrial facilities. I'm getting close to 1,000 different facilities on 6 continents. This is reporting on what the most secure sites do today. It's that far right end of the bell curve, the most secure facilities in the world. What are they doing for their industrial cybersecurity today? And why do we need to know that? Well, much the same as the advancement in the attacks. We talked about how the nation state level attacks from 3 years ago are today's generic ransomware that's used by cybercrime. Yeah, well, today's strongest secure facilities are the middle of the bell curve in the future. That's where everybody's going to be, in the middle of the bell curve in the future. And what's coming for the right hand side of the bell curve? Well, we can talk. We'll talk more about that over the next 2 days in this conference. That in mind, it's important to note that this is not opinion. This is what we've seen out in the world, more specifically what Andrew's seen out in the world with me chiming in from an editing perspective. So that's hopefully that settles that. And if you have questions, you want to dive into that more, please raise your hand, send it in the chat, send me an email, call me later. I'm happy to talk about it if people want to. I just don't want to go further down that rabbit hole because I've got other rabbit holes I want to go down. So starting with classification. Quite simply, it's impossible to secure anything if you don't know what it is. If I don't know what I've got, I can't secure it. If I don't know where my plant is, how can I build a fence around it? Think of it that way. If I don't know what assets I've got, then I have no shot at implementing the proper cybersecurity for them, because it is subjective. It is not completely objective at this point. So we need to be able to classify what we've got. First, we need to be able to identify. More on that later. But we also need to be able to classify, because one size does not fit all. I said that earlier. If I'm talking to a rural water association from whatever state, and I'm talking to a water operator for a system of 30 customers, that's an entirely different cybersecurity problem than the city of Toronto or whoever. So armed with that, some folks have gone down the road of let's classify this. NERC-CIP took a crack at it, mainly because they had to. The first iteration of NERC-CIP didn't have the bright line criteria, didn't have this 1,500 megawatt baseline to define what's required for what size facility. So if everybody was able to define what was a critical asset, what was a critical cyber asset, well, now the lawyers can get involved, and not harshing on the lawyers. Lawyers did exactly what they were supposed to do. They did exactly as they were charged by their company. But a whole lot of stuff that should have been classified as critical cyber assets wasn't, resulting in Mike Asante's very famous letter from, can't believe that's 12 years ago now. Wow. Anyway, that's one way to classify. Is how much power are you producing? How many customers, like in the case of the water utilities I mentioned. And then some other countries don't make a differentiation based on what particular vertical of power or water or hydro or they look at it more holistically. In Germany, the BSI, which is responsible for cybersecurity, and no, I'm not, despite my name Furstenberg, I'm not going to attempt the BSI. I'm just going to go with BSI. My German's not good enough. They've defined what is a critical system. Anything that could impact more than 500,000 German citizens. Done. It may not be the best classification system, but it is nonetheless actual classification. Similarly, in France, they've gone down the road of classes 1, 2, and 3. These have different reliability needs. That's why, and different safety needs. And that's why they're classified as such based on, on those needs. And at that point, they got more prescriptive about what types of cybersecurity need to be implemented. It's actually an easy read if you want to take a look at it. It's very informative. I'm not going to go into it because I'm not here to promote any individual country's regulations as better or worse than anybody else's. But yeah, that's really good. So I recommend reading it. Yeah. So with that said, let's keep it going. We talked about this earlier when we were talking about the 3 fundamental laws of SCADA cybersecurity. We started into it. The fact is, everything can be hacked. It is going to be significant. And because of that, we do have to regard every single information flow as an attack vector. We have to map it out. We have to inventory our information flows as much as we're inventorying our assets. It's a different exercise. It requires different peoples to be sitting around the table, but that doesn't make it any less necessary. This is where that becomes relevant. So, and we are getting closer to a break. So I know I've been talking for a while, and I'm sure some of you have gotten quite tired of hearing this sound, but so I do apologize, but it's the only sound I can make at this point. I'll work on something better for the future. That said, what are we here to talk about? Control critical networks. This is getting back to the 62443 concept, the IEC 62443 concept of zones and conduits. The control critical network, that's a zone. That is that industrial network that's, that's that's where stuff gets made. That's where the process runs. That's the network of machines that are brought together to deliver the product. So what can happen there is what we're talking about, and this is where we can start looking towards build documentation, build guidance like IEC 62443 in combination with I forget who has brought forth the cyber PHA or the things of that nature, where you're incorporating cyber into the process hazards analysis. Consequence-driven cyber-informed engineering is a buzzword, a book by Andy Bachman out of INL, and a new way of looking at things to figure out where we're going. This is the design part. This is what we're about to get into, how we're looking at it, and remembering that when we're looking at it as the system, as the line, as the process, but other people aren't looking at it like that. The attacker, what do they see? They see a target. think back to days in university where, the mechanical engineers build weapons, the civil engineers, what do they build? Targets. Yeah, that's that's what we're talking about here. It's just on the software side. Once again, the parallels between cyber and physical are more relevant here than the parallels between information security and cybersecurity. What we're doing when we're protecting a process, we should be looking towards an alignment with physical security, not necessarily an alignment with information security. When we think back a couple slides, we're actually trying to protect ourselves from the information. We're protecting the physical operations from the information. So that's where we get to online and offline perimeters. This is what we're going to jump into pretty quickly. And I think I just stopped sharing that by accident. And so you get to see me really, really large for a second while I bring it back. And share screen, application window, slideshow. This was so much easier when I had my clicker working, but battery ran out. Anyway, online and offline perimeters, and this will be the last slide I'm going to talk to until before we take a break, mainly because I need a glass of water and it's time. So that said, online and offline perimeters. It's not just defense. Defense has a cyber equivalent, and we've got to talk about what's effective, what's not effective. We've got to consider that our controls have to be online and offline. There's no point in putting up a fence and screening every inbound person for a laptop and a USB key and a USB cable for their phone and whatever else, and what hidden Wi-Fi, and we can go through all of these scans. And why would we do it if we're just going to put it in a router or a VLAN or a firewall that we're opening up 83,000 holes in? We've got to ask ourselves these legitimate questions that we're going to get into over the next couple of hours here, because if we're only doing half the job, then we've left ourselves wide open on the other half. And we know that, number one, the nation states, the military, the intelligence folks, the hacktivists, the true believers, they've got time. They're going to find that we've only secured this half and not this half, and they'll go after the easy half. Similarly, to the organized crime, that's where they make their money. They're going to find a way to make their money. They're going to find the easy way to make their money. That's the whole point of their business. When we think of the script kiddies, that's them too. If we've made certain things difficult, but certain things we haven't addressed, well, it's water flows downhill. That's what we're gonna end up with. We're gonna get those attacks flowing into the easy pathway in, and that's where we've got to make sure we're looking at not just our online perimeters, but also our offline perimeters. So we're going to talk in the next in the next session here, after a break for a couple of minutes. We're going to talk more about a lot of these types of controls, because they're relevant. That's going to be our upcoming agenda. So with that in mind, I am going to look at my watch here, and I've got 2:18 p.m. I would propose. What do you think, James? How much of a break should we look to here?
I would just take 10 minutes, if that's enough for folks to stretch their legs, get something to drink, use the lavatory, restroom, whichever terminology is most appropriate there. And get up and stretch about. So if we come back in 10 minutes, the workshop can continue from there. And if folks need to take a little extra time, to be honest, Mike, it's completely up to you. I don't know how long your content is and how much Q&A you want. So Eamon kind of ran out of time and we didn't get as much Q&A on his.
Yeah. So, that's an excellent point, James. And I hate to limit Q&A. And I've met me. I know I will talk until somebody tells me to shut up. So maybe what we do is when we come back, we do some Q&A on that first little section that with all the background information, take some time, get through some Q&A there, and then we'll jump into more of the offline controls and more of the content going forward. And we can go back and forth that way.
Cool. So we'll see everybody back in 10 minutes. And I'm just going to say 10 minutes because we're all in different time zones. So we'll resume in 10 minutes.
All right. I hope everybody makes it back. I hope I didn't bore everybody. Hope you're awake to take a break and not, I didn't put you to sleep. See you. Works better when I turn the microphone on. For anybody who's back, please do get those questions in. Q&A is great. It's a time when instead of you hearing what I want to talk about, you get to hear what you want to talk about. So when you're ready, by all means, get those questions in. Raise your hand if you're going to come on video to ask your question live. And we're going to wait one more minute, and at half past, we will start up again.
So, looks like we have Exelon here today. Good to see you, Nathan, if you can hear me. Feel free to chime in. You can always share your camera if you're interested. It's great when everyone fills out their profile. We can actually engage. Fortunately, some aren't as well, but some of these folks we know.
Nathan, you got to get better bandwidth. Jim's gonna come after you tomorrow or sometime over the next couple of days. I don't see any questions coming up in the chat. If we do, if they do come in and I don't happen to see them, please do stop me. Somebody interject, yell at me. I promise you I won't be offended. Quite to the contrary, I live in New Jersey. It is part of our culture to interrupt people. It will make me feel at home if you interject. So,
okay, we got Abdul Sattar coming on.
Excellent.
Hey, Abdul, how are you?
Hey, James, and I'm good. How about you?
Good, thanks. If you have some questions, go for it.
For sure. Yeah. So I guess I'm curious to get Mike's thoughts on how relevant would IT intrusion detection systems be for OT environments?
Okay, so the relevance of IT-specific intrusion detection systems as opposed to some of the more focused, focused on process control IDS systems that are out there. Is that the concept you're going on?
For sure.
Okay.
So essentially, I mean, I'm at a telecom, and I'm leading I'm leading the cybersecurity analytics efforts over here. So what we are building in house is an intrusion detection system that can handle billions of events for IT systems. And we are using behavior analysis and AI machine learning efforts along with let's say rule-based analysis and alerts from other SIEM systems and whatnot for doing some sort of for doing intrusion and threat detection use cases, right? I guess I'm also exploring at this point various other IoT use cases like connected and autonomous vehicles and smart cities. But I'm also specifically interested in OT as well. I mean, in IIoT essentially, let's say, and I just want your thoughts on how relevant would, let's say, like something like an ideas for IT, like how relevant would the approaches be for OT environments and for
So I did promise that the answer is almost always going to be it depends, and of course the answer here is it depends. And there's a reason for that. There's benefits to each side with the IT type of focus versus the specific control system type of focus. These vendors who have brought out intrusion detection systems that are focused on industrial automation, they've done some fantastic work. They've put in some the ability to decode industrial protocols, which will be very relevant in the IIoT space as well as the process control world. So, I mean, that's significant. They're also going to be have the ability to look for specific attacks that you might not be able to find in a basic IT-specific intrusion detection system. That said, there's going to be benefits to the IT side intrusion detection systems as well. The first benefit that comes to mind is scale and interoperability. If you're running the same IDS across all of your networks, whether they're process control networks, IT networks, IIoT networks, automated infrastructure networks, well, you've got economies of scale there. You've got the ability to ingest multiple things much more easily. Quick story from about, must have been about 2007. Was at a control system cybersecurity event. I was talking about incident command systems for incident response and using the FEMA model for response for plants. And somebody asked me, what was my preference from a cybersecurity perspective? Should I be running my HMI software on Windows or should I be running it on Linux? What server infrastructure is more secure for my? And I thought about it for a minute, and of course, there's open source. There's benefits to open source operating systems. There's benefits to proprietary operating systems, and at the end of the day, yes, that's an individual decision, but more to the point, and coming back to the IDS specific, the answer is whichever your people can support better. That's the more secure solution. If your people know Microsoft Windows, then Microsoft Windows is a better, more secure operating system for you than Red Hat. If your people know CentOS, that's a better, more secure operating system for you to be running. And similarly, when we get to the intrusion detection space, it may be that in order to take advantage of the economies of scale, that may be the way to go. You throw in the fact that there are prognosticators, crystal ball folks who love to tell us all that they know what's coming in the next year or 10 years or whatever, and they've told us that we don't need to worry about operation-specific attacks, that all the attacks are IT-style attacks, or attacks that we've seen in the IT space. So, the IT IDS will be just fine. It's entirely possible that the people making those statements, going back to my original point an hour and a half ago, it's entirely possible that the people making those statements work for an IT-based intrusion detection system solution. So they would have they'd have quite the motivation to say that. The reality is there's still not a one size fits all. Maybe it's a hybrid solution where you've got an operationally focused IDS running on your operational networks, feeding information into an IT-based console, IT-based IDS console on the IT networks, so that you've only got one SOC, you've only got one staff, and they're only using the one system they know, but they're getting fed information from other systems. Is that a possibility? Sure. Is it the right answer for everybody? No. Everybody's got every facility, every company's going to have a different answer there.
Sounds good. Thanks, Mike.
My pleasure. So yeah, I warned you. It depends is going to be my answer. I'll take it a little further always, but it's always going to be the start. Is it depends. So James, do we have anybody else wants to jump online, or should I jump back into the fun and games of talking about what I want to talk about?
I think we're good to go. Yeah, we're good to go.
What if what I want to talk about is country's U-23 dismal showing yesterday evening, so we can't go to the Olympics again? No, that's not what everybody came here to talk about. We're going to talk about offline controls for a little bit. So, this is it's not all about cybersecurity. Isn't all online. It's not always that coming over the wire. We tend to think about it that way. It gets sensationalized a little bit. But it's the hot thing in the movie and the TV show, but it's just as relevant to do the offline survey, to make sure that we're looking at all classes of cyber attacks. Just because it's not online doesn't mean it's not a cyber attack. It's important to remember that, and we've got to look at all of it. So, what are we talking about? We're talking about removable media, and it's not just removable media. It's not, I'm not going to talk about floppy disks, so don't worry. I am that old, but no, it's not all USBs. It's not all portable hard drives. It's portable laptops. The vendor, the integrator, bringing in their own equipment. It's a cell phone. Everybody's got a cell phone, and it's not a phone. It's a computer. It does actually work as a phone. So, if you need an immediate response, call me on it. Don't text me or email. But that's for a different time. It's all those non-permanent computers, anything, the cell phones, the vendor laptops, etc. It's also people. People can be an offline attack. We carry data in our head. I love that commercial and I won't mention the brand, but it's the consultants, and the one person is saying, "Yeah, I got everything I need right up here," and he slips and he bangs his head and knocks himself out, and nobody else can lead the conference call. So, yeah, and then of course you get into the exotic with wireless, blended attacks and different kinds of wireless and attack tools that can be drive-by and drones and so on. It is all relevant. It is all still valid. And that's what we're going to get into with all of this stuff. Starting with test beds. Test beds are, they're necessary. Nobody is running any kind of process without a test bed at this point. Even that 30 customer water company, we've got a test bed. And a control system test bed, it's a tool for us. It's supposed to be a fairly accurate representation of the actual process of the actual ICS, Industrial Control System, if I didn't spell that one out earlier. But, that's where we're going to test software updates. That's where we're going to test any changes that we're making. And we're going to, make sure it's instrumented for security so that we know what our security systems are going to be able to notice when the change does happen in production. And oh yeah, production, that's the plan. Production is the plan. I remember a meeting, 2008, internal company meeting. We're all sitting around at a hotel conference room, and the maintenance teams leads, the production superintendents, a couple of directors, and this was the first time we had invited IT to the party, as it were, to our semi-annual SCADA convention internal. And we're talking, and the IT network architect has just heard about some of the advances we're talking about doing over the next 5 years. This is part of the planning. And IT network architect starts chiming in, going, you're talking about all these changes to the production network. We've got, I'm not sure we have the bandwidth. That can't go on the production network until it's tested to make sure it's compatible with this. And you can't put that on the production network because it runs this operating system. And on the production network, we only allow that operating system. And he went on for about 4 or 5 minutes until one of our maintenance managers, engineer out of Western Pennsylvania, raises his hand and says, "Excuse me, exactly what do you think we produce here? We produce water. My network is the production network. Your network is a data network, an IT network, whatever you want to call it. But my network's the production network." So, sorry, story. I got all, and I realized it about halfway in, but I couldn't stop at that point. The production network is the plant. When I'm saying the production network, that's the plant. If you use production network internally to your organization to mean the IT network, good for you. If that's your corporate culture, go with it. I'm not here to change your corporate culture. I'm not here to tell you what needs to be called what. That's not my deal. But when for vocabulary purposes, when I say production network, I mean the plant. I'll refer to the IT network. I'll refer to the enterprise network. On occasion, I might say business network colloquially, but anyway, the point is production network is the plant. Test beds, back to the subject at hand, test beds exist, but test beds do not go on the production network. They cannot be connected to a live control critical network. That's because this is where we do testing. And if things go bad in testing, we don't want them to affect the real world where our people are and could be affected from a safety perspective, where our product is made and could be affected from a safety or quality control perspective, and so on. All the things we've already talked about. It's okay to put that test bed on an IT network if that's appropriate in your organization. It's going to depend from organization to organization, and it's going to come down to a risk evaluation to see, where it belongs. Does it go on IT network? Does it go in its own island network? Is it its own zone within a larger subset? Understanding that it is not control critical. Removable media protection. This is something we see at really all of the leading facilities we go to. It's not new. People have been doing this for over a decade. You know, it's noteworthy. You know, there's for those who think back in time to certain exploits being brought in on dropped USB sticks in the parking lot or carried in similar ways on other removable media, CDs, DVDs, etc. You know, there's got to be some security controls to deal with it. It's not a new problem. Some of them may be automated policies. Some of them you may have anti-malware screening stations. Not going to say brand names, but you know, we all know who they are. They've been around. They do it great. Scanner, a kiosk, where you're going to scan whatever removable media you're bringing in against anywhere from 6 to 40 different antivirus applications are going to scan it. Anti-malware applications that can coexist on that scanning station, on that kiosk, because of the way they're put together commercially by these kiosk manufacturers and these service providers. You know, it's wonderful. That's one way of doing it. You can do it automated. You can deny all removable media. Heck, you could do it physically. You could put epoxy in every one of the USB sticks, every one of the USB ports. That's a little short-sighted, for a couple reasons. First of which, I happen to have a keyboard that plugs into a keyboard port. I don't happen to have a computer that has a keyboard port on it anymore. Every keyboard these days is USB or Bluetooth. Same with a mouse. If you've epoxied shut the USB ports on the HMI, well, you might have a little problem actually using the HMI. Just say, think about it before you do it. And it's not just the USB ports. You go back in time. I had plants that the HMI software we were using required a physical key to be physically plugged into, get ready for it, old heads, physically plugged into the LPT1 port, into the parallel port on the computer. So, the physical connectivity was necessary. That was the license. That was you got a physical key as a license that plugged into a parallel port on the computer. If we had taken steps as a company to ensure that nothing could be plugged in to our HMIs and anything in the control room, well, I've got a real problem now, because now I've got HMIs that I can't license. And if I can't license them, they're not going to do anything. So, physical protection, physically disabling these devices, either that way, or you could go the easier way and disable them in BIOS. That's still software, not physical protection. But these are all things you can do. It's just consider it carefully what you actually are doing. So this is an interesting concept. Near miss protocols. This is something that's been around for decades in a number of fields, just not in cybersecurity. In cybersecurity, the far right end of the bell curve that we talked about, yeah, they're doing it. They've been doing it for years, not decades. They're not the FAA. They're from a safety perspective, and my security programs team was part of our health and safety team, it was reported into. So we were exposed to the concept of you report when things could potentially lead to a safety incident. And that's effectively a near miss in FAA terms, but we should be doing the same thing when it comes to our cyber protections. Potentially compromised media coming in, violations of procedures, anything that could create a new connection that would be a threat to our safety and our reliability. These are the type of things that could be reported as a near miss. And that, why is that relevant to these companies at the far right end of the bell curve? Well, it does a couple of things. It creates that feed for this is what's actually happening, so we can be practical about our cybersecurity program today. It additionally tells us what we need to do to make our cybersecurity program better tomorrow. These are the new policies we need. These are the new technologies we need to be able to advance our cybersecurity program. But what it does mostly, that I saw and that Andrew saw, and he remarks often about it, it creates a culture of cybersecurity, just like we talked about earlier today with the culture of safety, starting out every day with the safety minute. The fact that it's ingrained in every way that we work. Well, these companies at the SecOT end of the bell curve, yeah, that's exactly where they are from a cybersecurity perspective. They are to the point where that is their culture. It has been a fundamental shift of how they do business. And it shows. It shows in their how they handle removable devices, amongst other things. They might just not allow any removable devices by policy, and because they have the culture of cybersecurity, if somebody pulls out a USB key, if somebody pulls out their laptop and that laptop's not supposed to be in the plant, it's going to get reported. And it's going to be forbidden from so it's going to be all stop. Let's regroup and go back to first principles here. This does not come into my production network because I don't know what this is. This is not an asset that was defined as part of my network. Plain and simple. That's not appropriate for everybody. A lot of folks can't operate their facilities in such a way. There are other ways that you can enforce this type of situation, this type of ideal, this type of policy, without going full on culture. You could do it with technology, with something like network access control, where you're preventing anything but the authorized devices from joining the network, putting other stuff into a quarantine network, or just not allowing it at all. All viable alternatives given the individual facility, if it's appropriate. It's not going to be appropriate everywhere, once again. Sometimes it might just be better to do alerts. You don't want to alarm on the control on the HMI. In my opinion, there are places that do, but in the SecOT world, you don't see too much alarming SecOT alarms on the operator workstation, on the HMI, simply because those alarms have got to be process focused, and we don't want to distract from the process there. And so on. You can do it contractually. This is coming into vogue now. Over the last couple of years, we see a lot of supply chain cybersecurity discussions going on. It's not going away anytime soon. It's here to stay. Whether if you're a supplier or a provider, get used to it and figure out how you're going to go on selling and responding to your customers and doing what you're supposed to do in order to providing them with what you're supposed to provide them so that they can do their due diligence. And if you are the operator of the essential service, if you're the facility, even if you're not required from a regulatory perspective to go into supply chain security in depth, it's just generally a good idea. Oh yeah, this isn't new either. Once again, go back to 2006, take a look at the multi-state ISAC, the cybersecurity guidelines for cybersecurity procurement language for industrial control systems. Fantastic piece of work. Still relevant today. I don't know what version we're up to, but that's the basics. That's where to start. It doesn't have to be that complicated. And there's other things we can do besides contracts, supply chain security, all the knack and technology. I mean, we could just simply label the ports, put appropriate labels. This network jack is production network. This network jack is IT network. Okay. Provide USB chargers for phones so that nobody's plugging their phone into the HMI and to charge it during their overnight shift when they're alone, and because they were pirating music and some of the pirated music came with, or movies or whatever, came with some extra features, shall we say. Those extra features now end up on the HMI and affecting production while we got a real problem. And yes, that is a real story. Yes, that did happen. It's these are not theoretical. These things actually do happen. So, all of that said, it's new stuff too. It's the switch. It's the new computer. It's the new PLC, because that PLC does in fact have an Ethernet card or some communications card. It does have a processor. It's a computer. All of this stuff needs to be tested on our test beds. That's why we have them. Can we go seriously in depth? Well, that's up to you. How deep you want to go with your testing, that's an individual decision based on the level of risk for your organization, for your facility, for that particular, and you've got to work it all the way back down to the device, from the organization all the way down the hierarchy, to see how much is reasonable to spend on this. And it's not going to be the same everywhere. Insider attacks are, that's a different kind of challenge. It's not just the bad actor, the bad apple that we think of that could be the insider attack. Insider attack just means somebody with physical access to our critical cyber assets. They have the ability to do something. That's an insider attack. So what do we do about it? Well, I'm not the NSA. I am not the BSI. I do not have that level of abilities and tools for my individual facility. What can I do then? Well, there's a couple things we can do. We can work towards an appropriate convention for AAA, for authentication, authorization, and accounting. These are the basics from an IT security perspective, but we've never really even gone down that path in bulk in the industrial world. And the SecOT folks, they most definitely implemented individual accounts. Everybody's got their own method of authentication. There's going to be individual authorizations, role-based control, RBAC, and all of this is done for auditing purposes, auditing and forensics. In doing all of this, you've got the ability now to go back in time, and it may require the video camera and the DVR to go see who was actually sitting at the HMI at the time. If you don't have those individual accounts in place, but that this is now our attribution. This is our investigation tools. This is relevant because it is a deterrent against a lot of these insider attacks if it's known that you're being watched, if it's known that you have individual accountability. And it doesn't always have to be that technology. Once again, you can look towards the actions, the policies. What one big component of this is having a proper personnel surety program. That's where we make sure. That's where we have a program often connected with HR or with the relevant union as need be. That's how we evaluate insider risks, by evaluating the people. It should not be a one-time thing. We see that middle of the bell curve is doing a personnel surety program. Absolutely, we do a background check on everybody who's going to have access to our industrial facilities, and some of them will even, as we get further to the right of the bell curve, we'll see some psychological profiling. We'll see some credit monitoring. But once we get into the SecOT realm, we see all of it happening on a periodic basis because people change. I've changed. I know I have. For starters, I had hair when I started doing this. The fact is, people are changing. People are always going to change. If you are only looking at your personnel point in time on the date of hire, well, you're missing. You're absolutely not seeing the whole picture anymore. It doesn't. I make the distinction, and a lot of our SecOT sites make this distinction as well, that deceived insiders are different than generic insiders. It's an entirely different class of attack, because all of that accounting prevention that we talked about, all of that, it's irrelevant when you're deceived, because I'm not aware. I, as the insider, am no longer aware that I'm doing something wrong. I could be perfectly well-meaning, doing what I thought I was told to do as instructions in an email from a supervisor or superintendent or whatever authority, or it could have been a phone call with the vendor of my turbine or my VFD, and I think I'm doing the troubleshooting that they've asked me to do, that I'm supposed to do, but in reality, because I've been deceived, I'm screwing some stuff up. And this is where things can get a little bit different. And this is training, plain and simple. This is training your people, training the insiders to be suspicious of basically every bit of information that's coming in. We know that every bit of information can be an attack, and we know that offline attacks are just as important. That's what we're talking about here as the online attacks. The offline attack being the phone call, the email that comes in on my phone because please tell me you don't have your email on your control system. Let's hope everybody's past that. And anyway, it's all about training. We've got to train our key personnel to validate any bit of data, any bit of information that is coming from any external source before taking action on it in the production system. That's where safety problems happen. I've seen at a couple. We used to have a blue book that we called them blue books. They were actually white, but we had our blue books that would detail every bit of operation that we needed to do, and that's something that you can still do by training your on-site personnel. Basically, whitelisting isn't just technology. Whitelisting isn't just this is what I can put on this particular CPU to make sure that only these instructions get executed. We can do whitelisting by policy for people too. These are the acceptable sources of information. These are the acceptable actions you can take, and go into detail that way. It just makes sense. Once again, we can translate the physical world to the cyber world, and that's effectively what we need to be doing for our space, where it makes sense. Non-essential equipment. Well, if it's not essential, why do you have it? Sorry, that's a bad habit. There is non-essential equipment. It's just a fact of life. There's always going to be equipment that doesn't have to run all the time. The engineering workstation doesn't have to run all the time. Is it essential equipment? Yes, except when it's non-essential equipment, when it's off. This is, it's also true for the vendors' laptops as well. These are powerful tools that have all kinds of access and ability to do stuff to our process, to make changes, significant changes that could have horrible effects in what we're trying to protect. Best practice, anything that is non-essential at the time, make sure that we've got the appropriate AAA on it and keep it off, or at least offline until it's essential equipment again. Because why would we risk the exposure if we don't have to? So, made it through our offline controls in record time, maybe. And like I said earlier, please do interject with questions. I'm not going to be offended. I take it as a compliment. It means you are actually listening. So if you've got a question, don't wait for me to stop talking. That day may never come. Just ask, interject, tell me to shut up so you can ask the question. I'm good with it. And I'll try to remember to flip back to the Hopin screen so I can see if there are any questions in the chat. I'm going to do that right now. And okay. Very good. So online controls. We've made it through our offline controls. We're going back online because, well, facing facts, this is what everybody thinks of when we start talking about cybersecurity. This is the key. This is where the movies are. This is where the hype is. So online controls, they're exactly what it sounds like. It's a speed bump in the electronics. What can we do from a SecOT perspective? they're looking at one layer of unidirectional technology. That doesn't mean every zone and conduit, the conduit is unidirectional. It does not mean that. It means that there is one conduit that for all of these SecOT facilities that will be unidirectional in its nature. Typically, it's going to be between the control system network zone and the IT network zone. You may see it between an SIS network and a control system network. But this is what they're doing for online controls. Later on, we'll explore a bunch of the ways that these SecOT facilities are doing this. But before we do that, we kind of have to think about why. Why are they doing this, and why does it make sense for us to have this one-way conduit? And for effectively why are SecOT sites, as the graphic says here, forbidding firewalled connections? It's just another nice way of saying it's their policy that that's not what they do. And we got to go back in time once again. Air gaps. And I know what you're thinking. I've been shouted at for 15, 20 years now. Every time I've said the words air gaps, oh, air gaps don't exist. Everybody thinks they've got an air gap. They don't. Yeah, okay. Got it. Understood. Air gaps are not ghosts. Some places do actually have air gaps. Remember that 30 customer water utility I was talking about? Yeah, that system's actually air gapped. Surprise! It can be done. Does it impede the flow of information? Of course it does. And why do we need that information? We need that information for efficiency's sake. I'll get back to that point because I still want to talk about air gaps. They are rare. You can't just say I've got an air gap or take somebody's word that we have an air gap for our facility. It is true. From all the audits, from all the site surveys that we've seen and heard about over the years, there's often going to be some form of external connectivity between the protected network and the outside world, whether it's a public network like the internet, a PSTN network, a third party. It could be, that the turbine vendor has vibration analysis tools on our network, and we've got a connection so that they get all of that reporting data, so they can notify us if we need to make changes. That is not an air gap. I thought I had an air gap. I said I had an air gap. That person over there said we had an air gap. We didn't have an air gap. That's the objection you're going to get a lot of the time when you say we've got an air gap, or an air gap can be a way to protect against online attack. There's no such thing as an air gap. Yes, there is. You'll hear people tell us the perimeter is dead. That's so 2009. I'm sorry, but no. In 2009, everybody was saying the perimeter is dead, and I can't believe I just did air quotes. Holy crap, what is wrong with me? Yeah, the perimeter is dead. What was a big theme, and it may be true on information networks. It is most definitely not true in our world of process control. That plant's got a fence. It's always got a fence. It's protecting something. Similarly, we need to have a cybersecurity perimeter. And it's got to be effectively comparable. I remember visiting a power generation facility. I'm not going to say where, because it would give too much away, and I'm not going to divulge. This is not one of the far right SecOT facilities. This is something else. So most impressive physical security I have ever seen in anywhere. So I get to their facility, and they have a 6-meter high fence with 6 strands of razor wire above. For anybody who looks at ASIS or any kind of physical security recommendations, this is well beyond what's necessary, well beyond even what's the higher end of recommendations. This is huge. It's enormous. And I pull up, and there's an automated gate. And there's a rather large person standing there in fatigues holding a rather large firearm. And that person just stands there. That's his job. Somebody else comes over to actually check my ID. Check my ID, look at me. Yep, that matches. Now you are authenticated. Now I'm going to check to see if you're on my authorization list. You are allowed in the facility today. Okay. Large weapon gets out of the way. I can speed up to approximately 10 kilometers an hour to snake through the Jersey barriers, which are there to make sure I don't build up my vehicle to ramming speed to attack the building physically. So I park, and I enter the building, and I'm in a reception area. In this reception area is a receptionist and another person in fatigues holding a large weapon. I'm authenticated with my ID again, checked on the authorization sheet again. I'm now okay, and they call the person who I'm supposed to be visiting, who happens to be the production superintendent at this facility. And she has to come get me because it's escorted access only in this facility. We enter the actual facility now through a man trap, which, by the way, is to date still the only one I've actually seen. Really interesting stuff. So I get my escorted access to the conference room. There's 8 people sitting there, and we're about to start talking. All of that was the physical security for this one facility. And right as we're about to start talking, production superintendent gets a call on her phone. And we can hear, because it's turned up all the way, about we need to change this variable, and you're the person on site who has change access. Can you log in and do it? So I'm thinking to myself, oh, it's going to be another 20 minutes before we get to talk about that. What brought me here today. I'm going to be late, and this, that, the other thing. And then she just looks at her phone, puts in a 4-digit code, changes the set point, and sits down and says, "We're good." Yep. This is where the physical security and the cybersecurity don't match. If I'm the attacker, what do you think I'm going after? You think I'm going after that site physically? No, of course not. I'll never get there. I'll be shot 83 times from Sunday. There's no point in it. But the cyber, that's easy, because it's obviously on the internet, and it's obviously very, very loosely authenticated, shall we say. All right, sorry. What made me go down that story? I don't remember. Anyway, let's think about online controls. All right, so we'll get into some of the reference architectures in a little bit. The more important question becomes, okay, if we are going to do these online controls, how are we going to do it? How can we make it practical? Because the reality of the world is there's fundamentally not too many air gaps anymore. It's an effective tool for those who need it. But once you get to a certain operational standard and operational level, number of customers, output, whatever it may be, we now need to take advantage of the efficiencies that we can gain from data analysis. Efficiency, reduction of E&O, that's why we have industrial automation in the first place. It'd be silly for us not to extend that, even further if we can and we have the need. This is where we get into all kinds of new structures and new technologies, not new technologies. To us, it would be new to those in an air gap, but things like a historian for storage, long-term storage. And then we think back to the SecOT facilities, that far right, doing this over unidirectional controls, one-way zones, one-way conduits between zones. It's not practical. If this DMZ and that DMZ and all these networks are unidirectionally transmitting and none can receive, well, then nothing's going to work. So it becomes an exercise in analysis. What is a control critical network set? Sets and groups. This is one of our favorite math classes from everybody's days at college, university. This is effectively, not what everybody's saying. This is not what ANSI in France is saying. This is not the guidance we're getting from everybody else. This is what we're seeing out of SecOT. The different layers of defense, different defense and breadth type of situations will require different layers of firewalls and networks, and it's going to be a more layered defense, and it's going to have basic minimums that we're going to need with internet firewalls and DMZ or DMZ, depending on your geography. We're going to need that IT/OT firewall, or we're going to need that IT/OT unidirectional technology. And we've got to make sure that all of these technologies that we put in, we've got to make sure we understand their strengths, their weaknesses, their intrinsic limitations, and fundamentally what they do and do not do. This is where we get into the design phase of secure operations technology. And what we've got to remember here is, I'm not trying to bash ITsec. IT security is appropriate for protecting information, and it does it well. The ITsec design it's not fundamentally flawed, but that doesn't mean it's appropriate for operations facilities. It doesn't mean it's appropriate for a plant. And that's where we come into a new way of thinking about what we're doing. And it's about risk. I've mentioned the word risk a couple times. I've also said a bunch of words on this page a number of times. And unfortunately, a lot of these words are abused, misused, and confused, and while they're being used. And this is not a Dr. Seuss book, so I'm going to stop doing that right now. This is the traditional way of calculating risk. It is a threat cross a vulnerability. These are not multiplication symbols. The X is not a multiplication symbol. It is a cross. There must be an intersection of a threat and a vulnerability. Those threats, we talked about the threat table earlier, and the vulnerabilities, the weaknesses in my software that would allow a threat to compromise them. Likelihood is an interesting piece. I'll come back to that, and consequence, of course. The lawyers will tell us, and they're absolutely right, that you have no lawsuit if there was no damage. Similarly, if there is no threat of damage in our world, if there is no consequence, there is no risk. I think I mentioned Configure being on just about every ATM in the world, about 95%. Yeah. And there's absolutely no consequence to it. It doesn't matter. It doesn't do anything on those machines. So the fact that it's there is completely irrelevant. And we should, since there is zero risk, the risk number is zero because the consequence number is zero, then that should be what we spend on remediating Configure off of those ATMs. So that's, where we're going. I do want to take a mention about the likelihood number is very subjective. We hear people telling us that over time the likelihood of being attacked is definite. So it's a 1. It's not a percentage. It's not a decimal. It's a 1. Okay, maybe, but that doesn't take into account the lifespan of the asset, which is limited. It does not take into effect a whole host of factors and variables that should go into the likelihood calculation. So as much as I, as a security vendor, security technology vendor, I would benefit greatly from everybody believing that likelihood equals 1 because that bumps up the risk calculation. It's just simply not true. We can't make that jump. It's a leap that is based on a fallacy. That doesn't mean it's zero either. We can't look back at history and say, okay, well, there's never been an attack on my specific brand of RTU, and therefore the likelihood is 0. That's flawed fundamentally in the opposite direction. The real problem with the likelihood number is that, we don't have a good way of determining that number. There's a bit of a challenge. There's a lot of challenges, actually. Just from the experts telling us that these things that I just mentioned are true, but also from the fact that nobody really wants to talk about any kind of incident in their facility for a number of reasons. It might be just that their corporate policy says you're not allowed to talk about it in public. Okay. But you might actually have a regulation that forces you to talk about it in public. So who can talk about it in public and what are they allowed to say might change how it's reported and so on, which will change our perception of what the likelihood is. This all is based on the concept that we have actually done a root cause analysis and figured out that the cause of the consequence was in fact a cyber attack. That implies that we had people who were able to do it. And that they did it. The reality is that probably didn't happen. We probably were focused on restoring operations, not on doing root cause analysis. If it happens again and again, then we'll probably start thinking about doing some root cause analysis, and we might eventually get to a place where we're bringing in IT forensic experts to help us figure out what happened to that CPU over there. But the reality is, anybody who tells you they've got a number for likelihood, it's pure conjecture. Consequence, yeah, we can get an actual number. Most of us know how much money we lose if our plant's down. Most of us know how much our raw materials cost. Most of us know how much a safety incident costs us, how much equipment replacement costs us. It's a fact. We can loosely define consequence in those terms. However, we can't fully quantify consequence because there's always going to be soft consequences, reputational risk. What does this breach mean to my company's reputation? Are people still going to buy my product? Are they still going to have confidence in my ability to deliver? That's up there. Environmental risk is significant, and that is always going to be a bit more abstract than the quantitative numbers we talked about earlier. And of course, we talked about safety incidents. How much is a life worth? How much is a limb worth? Those of us old enough remember that certain manufacturers actually put numbers to that back in the 1970s, and it didn't work out too well for them. So we've got that problem. Vulnerability continues to be a problem as well. People I've heard it 100 times. I've heard somebody tell me, well, I know what my vulnerabilities are. They get published. I just go, check the CVEs and I patch all my vulnerabilities. And if my vulnerabilities are zero, then my risk is zero. I'm good. I'm going home. I'm secure. Unfortunately, I think we all know vulnerabilities don't work that way. That makes a couple of false assumptions. It assumes that, number one, that all of the vulnerabilities that exist in our software are known. It is that they've all been discovered and there will never be more vulnerabilities discovered. Number two, decidedly says, well, all of those known vulnerabilities have been disclosed. And all of those disclosed vulnerabilities have a fix available. And all of those fixes are compatible with the process that I am running with that particular piece of software and compatible with all the other software and hardware I'm operating. And so on down the line. I think we all know that all of these are not true. It is not possible to reduce our vulnerability to zero. So that's our challenge here, is we keep looking for these quantifiable methods to share with everybody so that we can justify our budgets, so that we can justify what people, process, and technology we want to put in place to combat the risk associated with operating our process. And yes, that's exactly what we're talking about. We can't put a number to it. The threat we saw the threat table earlier. It's a list of words. It's not a number. It's a list of paragraphs. Vulnerabilities, we're guessing. Likelihood, we ran through that. Consequence is incomplete. We're trying to get a number out of this, and the inputs aren't numbers, and if they are numbers, they're made up. It's not an effective way for us to evaluate our risk. And if we use this to evaluate our risk and then attempt to communicate it, we are torpedoing ourselves, because anybody who looks at this knows it's not valid. Anybody who would listen to us make statements like this would know that it's not real. I tried to take this equation up to my executive management team to get budget for my security programs office back in 2002, and they laughed me out of the conference room. It's not going to work. I can tell you that from experience. So what is going to work. And this is a way to bring it forward. This is a way that we can justify our expense. We can justify the people, process, and technologies that we are going to implement in the name of security, making our process more secure than it is today. So, attack modeling. That's what we're talking about here. It's a simple question. What is the most simple attack that can hurt me, that can cause damage to my process? Either it can cause a consequence, as we talked about earlier, either safety or financial or whatever it may be. Well, I could answer that, and it'd be pretty much whatever I think. That's very, very useful to me, not to anybody else, and certainly not to that executive management team that I'm trying to get funding from. I need to put together a team. I need a team of people that's going to know how to evaluate what's going on. And it starts with physical security experts, because we've already established, if the IT security folks have been telling us for decades, if I can touch it, I own it. And they're right. And the same's true in our world on the process side. And that's why our physical security folks, they are going to lead this. They're going to be able to tell us what our insider threat is, what are the physical paths into our facility, and what is the risk of compromise there. Doesn't stop with them. We need our safety systems people. We need our IT people. Why do we need our IT people? Because they understand the cyber defenses that exist already. They understand that IT-based IDS that we were talking about after the break. They understand the firewall between the internet and the corporate network. They understand the routers. They understand the databases that we're publishing all this information into to be published into a nice, pretty portal for management. This is all, we need them at the table. They also have an understanding of how cyber exploits will attack cyber vulnerabilities better than anybody. We need them. We need the cyber attack people as well. Offense informs the defense. Talked about that about an hour ago. And on the last slide, we talked about consequence. We said, we need to know what the consequence is, because if there's no consequence, there's no risk. And we need the business people here. We need the accountants. We need the people who know how much we're spending and how much we're charging. These are the folks that are going to be able to tell us what the actual consequence is. And they're going to have to do so in conjunction with the folks who run that physical process, whether it's production or maintenance or whoever you can get to the table. Somebody's got to be able to say, yeah, if that box right there goes down, we can't run this line for 5 hours. We'll have to, this system, and where you have to reboot the entire system, not just this line, to get that box back. And so it's everything that's going to be down for 2 hours, and this line's down for 5 hours. That's who we're talking about. That's who we need involved in this conversation, because otherwise you get one person's opinion. You don't get collaboration. You don't get the actual picture of how the facility and the organization will actually be affected. So we saw this table earlier. This is who we're worried about. So how we're going to do this task over the next couple minutes is we need to know who we're worried about. We need those threat intelligence people that I referenced very early today. Why? Because we need to create a matrix, not the matrix. not going there. We need a matrix. We need a matrix of what these groups can do. At the bottom level, that bottom line there you see is everybody is just the threats. Who are the threats? Who is the attacker? And going up the table, going up in columns, we have an increasing level of complexity, effort, what they have as their capabilities. This is what they might be able to do to exploit an attack on our vulnerabilities to some consequence. Okay, so for the record, I feel like I have to say this because I've used this slide and these next couple slides in the past, and people have taken them and run with them. This is mine, and it was created at a point in time, and it was not in reference to any particular facility. You need to create yours. You need to create your cyber sabotage attack matrix with the threat actors you are worried about and what their current capabilities are. Don't take my word for it. I'm a vendor. I'm telling you from my experience, from my history, this is what I've seen. But you've got your own facility. You've got your own people. Write your own matrix. Don't take mine. If you take mine, you're going to get the same results I did, which are very accurate for the theoretical system that exists only in my head. I don't know that they're going to have any degree of accuracy for your actual physical process and your facility here in the real world. So what we're going to do now that we have our matrix is, design basis threat. We're going to draw a line. It's very, this is something I just love because now it becomes an exercise of all of us in that group that we established earlier with the ICS programmer and the maintenance supervisor and the accountant. We're going to go around the table and we're going to discuss what we have today. Is it going to stop organized crimes ransomware? Is it going to stop this remote targeted ransomware? Maybe, maybe not. We're going to go through that exercise. This then allows me to figure out what I want to do technology-wise. So, that previous slide, I might have just had a kiosk for checking things in and out. And now I'm proposing upgrading to a next-gen firewall at the border, and oh nuts, the line didn't move. I just spent a fair bit of money on technology, a whole lot of money on people to program that technology, and oh yeah, I got to pay them forever. But and I didn't move my line. Well, what if I also throw in all that new device control type stuff and crap? My line didn't move. We just sat around the table and bounced that around for 40 minutes. Of course, in this particular exercise, once again, all 6 people running this exercise exist only in my head. Therefore, you've got to do this exercise for you. What if I go up to a unidirectional security gateway, take that SecOT advice and say 1 layer of unidirectional security? Now I've moved the line. Okay, good. What if I take it a step further and I also do it with that device control that we were talking about, and I throw in an awareness program? Hey, now we've really got the line moved. Life looks pretty good. I like this. Now I've got pretty pictures. I like to take my pretty pictures because they help me get budget. They got me funding. That's how I got my department funding. That's how I got my new technology. That's how I got whatever it was that I was trying to get. I could show pretty pictures to justify that we had agreement amongst all concerned parties about what would be effective in terms of actual risk reduction, in terms of actually moving the line of what we can in fact protect. So I think we probably reached another good point for bio break. It's roughly 12 minutes to the top of the hour. So I'm flipping back and I'm seeing some questions, and I'm going to ask James if you want me to take a stab at these questions now, or if you want to wait till we come back from bio break, or
why don't you go ahead and take any questions now? Hey, do you mind if we share your PDF?
That's why I sent it over.
Okay, just making sure because I noticed you said don't take my matrix, so just double checking. It's okay.
Yeah. Oh yeah. Whatever. No, use the matrix concept.
Yeah.
Use the graphical concept. It's not mine.
Okay.
I didn't make up design basis thread. It's been around for 60 years.
Okay.
It's a great concept and it's entirely appropriate. What I'm saying is don't use my actual matrix. You've got to figure out with your team where your line is and what technology, what people, what policies will actually move the line in the direction that you want it to move.
Okay.
So
folks, if you have any questions or you want to come on to the video and come on screen and talk to Mike and ask your questions, please do. There's a share video and audio option in the upper right-hand corner of your screen. Just click on that. We'll let you in. Mike, do you see any questions other than mine?
I only see, yep, that's just what I see is the comments from you and questions from you.
Yeah. We ran a few rail shows recently, and air gaps were kind of a big topic. And
always have been. It's a big time safety issue in rail. You've got people working out on the tracks, and you've got some really heavy stuff moving at some really high speeds. We've got a real safety issue and that's just for the people working. I haven't even gotten into the people riding on the train or the cost of the cargo if we're talking about a freight train, because that's significant as well. So yeah, it's not surprising that actual air gaps exist in that space. I've worked with a couple of light rail folks, and it's in terms of getting information out to the general public, in terms of getting data out to folks on the line. Models like this with a single layer of unidirectional zones and conduits, they work for those folks. Especially in the passenger space where it's right before the pandemic hit, and presumably as we make our way towards a new normal, we were looking at a couple of drivers. Significant drivers, mobility as a service, as well as increased ridership for environmental gains and city center accessibility. All of this leads to a need for increased efficiency and increased communication. And the question becomes, in order to do that, we need data transfer. We need information to go from one zone to another. How do we do that and still maintain the line in this matrix that gets us to the level that we're supposed to be at, or the level that we want to maintain. So that's always a fun question. I'm sure that the Cyber Senate rail conferences and symposiums are going to be continuing to create a space for that information to be shared appropriately amongst the operators and track owners and so on.
Yeah, most definitely. Thank you. So we have 41 folks listening in. Don't see any questions. So now would be a good time to take a break if you want to, Mike.
I think that's appropriate. Make sure everybody gets their bio break, get some water or whatever it is that you want to drink. If anybody's playing the control system cybersecurity drinking game at home, I could say the S word so that you have to take a drink if it's that time of day for you. Just give me a message so that I'll say it so that you know. But my preferred option at this point is water. It's not just because I've spent too much time working for water companies. That said, I've got 6 minutes to the top of the hour. I would propose that we come back at 5 after. We'll take a 10-minute break, +1 for general conversation and introduction when we get back.
See you at 5 after the hour.
All right, we're getting close to coming back time, which will be at 5 after the hour. I'm showing 4 after the hour right now. Just a reminder, questions are good. You know, if you don't want to come on camera, by all means, just pop them into the chat window. Well, we can even wait an extra minute so you can create a fake ID on Hopin and ask the question under an assumed name. Please don't do that. I did not suggest that, not out loud. It's or send me email if you don't want to talk in public. And I did mention that I would get back to that point earlier. So now is as good a time as any. I guess it was about 2014. I'm sitting in a law firm for a power producers, power generation conference. Not a big one, maybe 65, 70 people. And we're talking about security. And, it comes up, the discussion turns to Google Maps, Microsoft Earth, and all the nuclear facilities. They aren't shown on Google Earth. Microsoft Earth doesn't show them. Why are our substations? This was right after San Diego, or not San Diego. It's not coming to me. Large substation got shut up. Why are our substations allowed on Google Maps? Why are conventional generation? Why are hydro facilities allowed on Microsoft Earth? We need to petition to have all this taken off. And I'm sitting there in the back of the room thinking to myself, why? You think people don't know where they are? Yeah, everybody knows where they are. We can see them. They're there. What is the point in removing that information from the internet? And it goes further. The discussion keeps going. And eventually I had to say something because it got absurd. The whole point here is open source intelligence. The reality is all the stuff that we think we can't talk about in public because God forbid somebody should find out. Well, the fact is they already know. For starters, based on our geography and what we produce, what we do, it's down to probably about 2 different control systems and a couple different PLCs. There's not much mystery here. It's known what we're running. Oh, by the way, a lot of this infrastructure is public, and the capital investment, we want to recover it in rates as utilities. So yeah, that all has to be submitted. All that information has to be submitted to our Public Utility Commission or Board of Public Utilities to effectively, be able to recover the capital investment in rates. So it's a matter of public record. Everybody knows what we have. Even if we didn't have to do that, the RFP was public. Could have got it through Oprah if it was for some reason not published. Then you can go down the open source route. This person works for X Power. Let's see what they list as their what they're familiar with programming. Oh, okay. We now know what package they're running for EMS. Okay. To be able to sit there and say that our security depends on the fact that nobody out there in the world who's not us, none of them know what we have. None of them know what we use, either for our process or for our security. Well, cybersecurity depends on the fact that nobody knows that stuff, we're sunk. It's over before we started. Because I'm here to tell you, everybody knows it. It's too easy. So yeah, that's where I wanted to go with that. So before I jump back in, we've got 51 minutes, and I promise I will end on time. I'll try to end a little bit early to give people a little bit back. But you know, I want to make sure that if we have any questions, we're doing that before I jump back in, because once again, it's much more important that we talk about, you know, what brought you here today than what brought me here today. I was going to be here talking anyway, even if I was the only one. So sorry. So James, if has anybody contacted you saying, "Hey, I'd like to ask you a question"?
I haven't had any, no. But I
Right.
have had plenty of people sign up for this, and I know they're listening and enjoying it. Don't know why they're not engaging. Engage people. To be honest, we don't ever get as many questions as we want. We always want more engagement than we get. And I know it's beneficial for people, nonetheless, to listen. And I know Eamon, when he does his, is quite technical. I don't follow everything he's talking about, but some people do. Anyway, by all means, folks, please ask questions. We're ready for you.
I love questions. Yeah, Eamon and I go back a long time to a time when neither of us were vendors. That's how long. And he's absolutely fantastic. He knows his stuff. He can go down in the weeds at a technical level. He can go up to the executive management and board of directors, 50,000 foot level. He's an amazing person, and I'm honored to be following him here today.
Thanks. Yeah, we've been working with him for quite a long time, so it's great that everyone knows each other.
Yeah, it's a small community. I mean, especially back in the day, we were, a couple hundred of us. I'm excited by the fact that we're getting into the thousands and tens of thousands now. So that's good. So I'll jump back into the PowerPoint because, hey, why not? And, this next section is all about network design. These are 20 networks that we see over and over again. This is how these sites on the far right of the bell curve in these secure OT sites, how they set up their networks, how they design their networks. And these are the 20 most popular things that they're going to do. And they're all going to have at least one layer of that unidirectionality, that one-way conduit between zones. Why? Because that's what breaks the kill chain every time, reliably. If there's no path in, then the kill chain is broken. For everybody who bemoans the fact that the attackers only have to succeed once and we have to succeed every day, that is true, but it's also misleading. We don't have to redesign everything every day. What we have to do is do the design properly in a secure OT philosophy once, so that our design reliably breaks the ICS kill chain every time. That's just a different way of looking at things. I tend to be I tend to be the type of person that when somebody tells me something's not possible or it's too hard or challenging and nobody can do it, that's when I get involved. And that's when I get disturbed. And that's why I've chosen to rephrase that particular statement, because it's true. It's also inaccurate and misleading. And when we make that statement, it discourages us from going down the proper design route. It also discourages the new folks that we want to show up and bring new ideas. You know, the fact is, the attacks are not getting any simpler. The attacks are growing. The attacks are changing. If we remain stagnant in our defense, we're going to have a problem. We need new blood. We need new ideas. And if we're discouraging people from joining our profession by weaving this tale of woe that it's so hard and we're fighting a losing battle, well, we're sinking ourselves. So, yeah, please don't do that. Anyway, 20 networks. Back to the, so yeah, sorry, I told you at the start, I go off on tangents, and hopefully I get back to what I'm supposed to be talking about. And hopefully the tangents are entertaining. 20 networks. So this is what we're seeing, and it all comes from the unidirectional security gateway, which for those who don't know, it's a combination of hardware and software. A lot of this is from NIST. A lot of this is from Wikipedia. A lot of this is from our website. Once again, see earlier caveats. So, it's hardware and software. It replicates servers, emulates protocols. We'll get to all of those kind of use cases as we go along through these 20 networks. But at the end of the day, what it is it's hardware enforced one-way information replication. Get the data into the hands of whoever needs the data so that we can take advantage of all those efficiencies that we're trying to gain. But when we eliminate the exposure of our vulnerabilities to the threats that would have attacked them and cause a consequence with some degree of likelihood, that's when we're actually affecting the risk equation, because that's the missing piece from earlier's discussion. Exposure. If our vulnerabilities are not exposed to the threats that would attack them, well, then we can actually reduce our risk. It really is, simple, and that's where something like this comes in. It's elegant in its simplicity. Data gets replicated in one way, nothing comes back. Everybody gets their information. The cyber attack never has access to exploit the vulnerability. The exposure is simply not there. So the most common way folks do this is by replicating a historian from a control system network to an IT network. Could be a SQL, it could be a branded SQL. This is where the software that goes along with the hardware is going to have a significant effect on the usability and viability of this one-way conduit between zones. It's replicating a database at this point. A historian, I'll translate historian equals database. That can be queried so that information can be known. If we have a replicate database on the IT network, that's exactly the same as the historian, with all the latest data less than a second old, and of course all the old data back to whenever the historian's time began. Now we've got the ability for clients on the IT network to now query that replica database without reaching into the production network. Why is that important? Because if they can reach into the production network, well, number one, who knows what they're reaching in with? Number two, what else can reach through that conduit? What else can take advantage of the fact that there is a path into the control system that could cause some sort of incident, that could be an attack? It doesn't have to be a historian. It could be as simple as device emulation. Could be multiple devices with an OPC server. There's some great OPC servers out there in the world, at various flavors. And you can emulate OPC over the one-way hardware. OPC, people tend to look at it and go, that's some old stuff. That's OPC DA. Are you talking about? Is that whole decom stuff from back in the 90s? What are you talking about? Well, it might be. For starters, first of all, there's a lot of it. OPC DA is still out there. OPC UA is modern version. There's also HDA for historical and A&E for alarms, events. All of that can be emulated across one-way hardware with the proper software, and that's where a unidirectional security gateway can show its value. This is, once again, just a way to get the data into the hands of those who need it, those who can create efficiencies, make proper business decisions, make proper environmental decisions, and so on, with real live data, but now without exposing our vulnerabilities to any kind of threats over the network. It's simple, it's easy, it's proven, it's been around for decades. It just does, and that's why these SecOT folks on the right side of the bell curve continue to use this. You can do it with applications. That's another way they're going to do it. And the thought occurs to me now, I'm going to blow through a bunch of these examples of unidirectional zones, because then I want to talk a little bit. I've got another presentation which isn't part of this, where I talk about firewall misconfigurations. One of the things I did before I became a vendor, I was responsible for the day-to-day care and feeding of a couple hundred industrial firewalls, and learned a fair bit about them in terms of how to deploy them properly, how to what to do, what not to do, how to break them. I started putting together some slides so that hopefully I can share some of that information with people, so that we're not making mistakes if on the firewalls layers for where we're using firewalls as conduits between zones. Same thing with the application replication as it was with the historian or the OPC, except now we're replicating an application. Might be an HMI. Generally it could be other stuff. It could be web servers, could be a web HMI, but still popular, to be honest. So all of these things can be replicated over the one-way hardware. Remote screen view, I wish I had that when I had my facilities. It's now, instead of replicating a database or a protocol, you're replicating pictures. One way, you're the operator or the engineer on the engineering workstation or HMI. They turn on the remote screen view client, and now I, on the outside, maybe I'm in a hotel, maybe I'm at home because it's 3 a.m. and the operator has a problem, and he calls me and says, hey, I've got this problem. Can you take a look? And I say, sure. I VPN into corporate. I connect to the web server on corporate that the remote screen view is sending pictures to. It could be as much as 30 frames per second, like live TV, or it could be 1 frame per second, because I don't, it's not changing that much. But now I can see exactly what the operator sees on the HMI screen, or the engineer sees on their workstation. It's not remote desktop. I can't do anything, but I'm on the phone with them, so I can offer expert advice and talk them through whatever problem needs to be taken care of at that particular time. This is huge for these SecOT sites. This is how they do remote support, internal and external. They do it with their third parties as well. That vibration analysis that we were talking about earlier for the large rotating equipment. If if that vibration data is now indicating that there needs to be a change, well, the person on the inside, the person on the protected network can make the phone call to the approved number, talk to somebody on the approved list, whatever authentication protocol you need to put in place between the two to make sure everybody knows who they're talking to and they've got the real deal. Now that expert vendor who supports my turbine, you know, whoever I'm talking to knows my VFD, knows my variable frequency drive. They know what's going on. They can see the vibration data live, and they can talk me through making the changes that I need to make to ensure the lifespan of my equipment is not reduced because of failure to perform maintenance under expert advice. That's what these SecOT sites are using this for. I'm going to skip a couple of these because I want to get to talk about the firewalls just a little bit. Network intrusion detection is huge. We talked about this earlier. It's not going away. You wouldn't build a fence without a camera. Don't build a perimeter without looking at it. You need your network intrusion detection. How you do it, on the other hand, you don't necessarily need to have that two-way connection through a firewall. It can create some challenges. This is one of those problems we see, problem areas where we see operations doesn't want to give IT access to the plant network, but corporate has said we need to monitor, and everybody's right. Well, how are we going to do it? We're going to do it with one-way hardware. We're gonna emulate the protocol, whether it's packet capture or TCP dump or whatever it may be. We're going to emulate that over the one-way hardware and feed it into the sensor on the IT network. That way we can maintain our single SOC for the enterprise, as opposed to needing separate SOCs for corporate versus production and so on, or separate SOCs for 200 different plants. That gets expensive really quickly. It's just not sustainable. This is the way to do it, and maintain that harmony that we've all come to know and love. Eliminate the territory wars of no, I need to put this here. No, you can't put it there, and so on and so on and so on. What else can we do? It doesn't always have to be the control system. It can be the safety system. Talked about this earlier. Sometimes you might find that this is, in fact, the exposure that we need to worry about. We might want a gateway in between the plant network and the IT network. We might not. We might definitely want a unidirectional conduit in between our safety systems and our control systems. We don't necessarily want our control systems to be able to control our safety systems. That's the whole point of the safety system. I'm not quite sure where we're going with the integration that we've seen over the past couple of years here, but that's not the vendor space that I occupy, so I can't really say what's driving that convergence there. I can only say that the designs we worked with, we would not have put the safety systems on the same network as the control systems. We would not have allowed a bidirectional conduit between the two. A unidirectional conduit between the two is perfectly permissible. That makes sense. So There's all kinds of other ways that we're looking that the SecOT sites are using unidirectional gateways and for their conduits. I'd encourage everybody to download the slide deck and the reading material that goes along with it. James put the link into the chat window earlier. That'll go through all 20 of these. I'm happy to go through all of them. I just think that might be a little tedious at the end of a long day for everybody. So I'd rather jump into something a little bit different. If I might, yeah, I'm going to blow through this. Yeah, we'll get back to the, and let me stop sharing there. And start sharing this. And I've got to find sharing. There we go. Share screen. Application. Slideshow. And share. Okay. So I want to talk a little bit about firewalls. This is the two-way conduit and why that is not helping us reduce our risk. You know, here's some attacks that have happened over the last couple of years. Everybody's familiar with them. They have actual cost. That's the problem. That's the risk we're trying to eliminate. This is the design we're trying to implement so that we can get data and do everything we're supposed to do without generating the exposure that comes with the firewall. So I do want to make sure that we're not going to get bogged down in all of these excuses over time, misconceptions. That is something I'm going to jump into a little bit more deeply tomorrow, so stick around. We already went through this. So here's what I want to talk about. I want to talk about 8 common mistakes that are made in firewalls. Why am I talking about this? I received an email last week from a firewall vendor, and I'm not entirely sure why they were doing this, but they were putting on a webinar about firewall configuration mistakes coming up, I think they said late April, and it had a statement in the email, and I don't want to swear to the truth of this statement because I didn't make it. This email from this firewall vendor says that there was a statement from Gartner that 99% of breaches are caused by firewall misconfigurations. And I sat there thinking to myself, well, then why the hell would I use a firewall? Why would I knowingly implement technology that is so difficult to configure properly that misconfiguration happens so often and is the root cause, according to this email, of 99% of the breaches? That being said, let's jump in. I want to share some basic misconfigurations. I'm going to blow through this really quickly. Maybe sometime we'll add this. If anybody wants to dive deeper into this, we can do that another time. Every firewall comes with an IP any in place. It might be explicit, meaning you can see it. It might be implicit. Typically, it's going to be permit any. Why is it permit any? Because when you get a firewall and you take it out of the box and you plug it in, if everything stops working, what do? You pick up your phone and you call tech support. Tech support costs that firewall company money. They don't want you to call. So, if everything doesn't break when you first put it in, then they're not going to call. You'll go theoretically to properly configure it. So you've got to know if that rule exists if it's implicit or explicit, because and what happens once you start configuring your firewall. Some firewalls, it's always there unless you explicitly remove it. Other firewalls, it goes away as soon as you implement the first actual access list element. It depends on your particular vendor. You've got to know what you've got. And speaking of that rule set of access list elements, the order matters. Not only does the order matter from a security perspective, I'll get back to that in a minute, it matters from a functionality perspective, because the rules do get processed in order. Think of it like a big if, then, else statement. If it matches the first line, okay, take the action associated. If not, go to line 2, and so on and so on and so on. And if you've got you've got to make sure your rule set has your most often hit rules at the top of the rule set. Otherwise, you can expect a performance hit. If you put them in the wrong order, you're going to have a problem, because the first match wins. It's if, then, else. And going back to that previous thought about permit IP any, if you've got permit IP any as your first rule, and then you start denying stuff after that, any is always going to go. What does that mean? Any device communicating to any other device on any TCP IP communication port. That's the problem. You can actually put in the firewall and leave yourself completely wide open. Disable your unused interfaces. This is huge. The firewall companies, they don't want that phone call. Nobody wants that phone call. It's not just firewall companies. Nobody wants a phone call, because anytime you want to talk to a person, it costs me money. So they're going to make it easy. They're going to give you all kinds of different ways to be an administrator. Web, some thick client, a serial cable, Telnet, SSH. All of these are enabled by default, because, once again, don't want the support call. Okay, so does that mean that I have to, if I don't disable them, they remain enabled, and that's another path to administration. If somebody else can administer my firewall, well, it's not my firewall anymore. That's the problem. Also, each of them might have its own password. All of those are going to be published in the administrative user guides and on the vendor's website. It's going to be common knowledge, OSINT. Once again, this is where we're at. We don't want to use a product that's this easy to allow exploits. And that's that default password I was just talking about. The world has access to it. And, I've run into people. I ran into a great situation with an external auditor who knew her stuff. She was sharp. She was auditing the firewall, and this was a beautiful thing. I still smile every time I see it. The organization being audited said, "Oh yeah, we didn't change the default password, but it doesn't matter because we use Active Directory for our authentication." She went over to the firewall and unplugged the network cable that was plugged into the network that had the Active Directory server on it, and now she could log into the firewall with the firewall's default password. It was absolutely beautiful. She was amazing. I'd hire her over and over again. Anyway, that's what we're up against. That's the technology problem. We think of it as hardware. We look at the firewall and it looks like a box. It's hardware. It's got a cable in, cable out, magic. It's hardware. It's not hardware. It's an operating system. It's firmware, and it's a rule set. The rule set problems we're talking about, but the firmware and the operating system, oh yeah, they need to be patched too. Why? I I bought thousands of firewalls in my life, and never once has a firewall vendor called me on my phone and said, "Hey, Mike, we're going to release a new patch next week for all those firewalls, and you might want to put it on there because it's going to be good." No, they don't do that. They put the patch out on their website. They publish what it fixes, and now everybody in the whole world knows what's wrong with the old version. And oh, by the way, if you think nobody knows what you're running, we already established earlier, we do know what you're running. And even if we didn't, we can scan you and find out. It's really easy. We can do it modern. We can even go old school and use some stuff like P0F. Passive OS fingerprinting does in fact have firewall operating systems in it. So be aware. Increasing costs. This was the biggest challenge we always ran into was the fact that they have an OpEx tail. Not only do you have all the costs associated with the infrastructure you have to buy, but there's always going to be an OpEx tail associated with the ongoing maintenance and support and the people to configure and maintain these firewalls and make sure all of these mistakes don't continue to happen. They cost money. And anybody who's here who goes with a rate case before a public utility commission, you already know this. OpEx is not recoverable in rates. So that's just cost for you. Of course, when we mismanage those rule sets over time, there's a number of different ways it can happen. 2:00 in the morning, Mike, I need this change. I need to get in. Okay, I make the change. You're in. I forget to back it out. Emergency repairs happen, and over time, the firewall just permits connections that looks like spaghetti. If you actually mapped out all the permit statements, it'll look awful, and it becomes a significant challenge to manage. And of course, last but not least, believing that I've got a one-way firewall. I hear it all the time. I've got a one-way firewall. I permit communications outbound only, and nothing could be further from the truth. It's a bidirectional protocol. TCP/IP is a bidirectional protocol. You've got no hardware enforcement of one-way conduits, and you've got no software. If you don't believe me, I got 4 words for you. SYN, SYN, ACK, ACK. That's the 3-way handshake. Guess what just happened? Bidirectional communication. So even though I've configured my firewall for one-way communication, what I've actually configured my firewall to do is initiate communications in one direction only. Whatever wants to come back can come back. It could be the response I'm expecting, or it could be an attack. How could it be attacked? Well, think about it from a web server through the corporate firewall. That attack's as old as dust, or as old as the internet anyway. Where the server that I'm connecting to has been compromised, and now, even though my firewall doesn't permit that server access into my protected network, when I go pull something from it, it sends an attack back to me. Done. That's the problem we're dealing with here. That's, effectively what the issue is. Why would we put out technology that's that easy to misconfigure? It doesn't make any sense when the stakes are as high as they are, when what we're talking about is protecting safety, protecting the reliability of the process, protecting the efficiency of our operations, so that we can continue to produce the products that we've been charged with in a safe, reliable manner, and hopefully enjoy the spoils thereof. That said, I could jump back to the other presentation, but I would rather hope there's going to be questions and and talk amongst ourselves for a little bit. If not, I'll launch into a wrap up, but I'll ask James first if we've got questions in the queue.
Okay, just looking. No current questions, Mike.
All right. Do you have any questions?
Do I?
Once again, I can talk about three topics with some degree of actual intelligence. I can talk about industrial cybersecurity. I can talk about football, also known as soccer, depending on your geography. And I can talk about alpine skiing. Other than that, I'm relatively useless.
No, I think that was it was a great great workshop, great presentation, very appropriate for today's environment. You know, and I suppose a question that I may have, I've been looking at supply chain quite a bit, and it's not so much a question, but you know, we're looking at product development and its impacts on the supply chain and how we might get better at this. There's already assets in the supply chain that we're going to have to deal with, which is what we very much have been dealing with for a while now in this industry sector or this sector. But we've been having a lot of conversations, and there's a water company that's going to be speaking on day 2 from Los Angeles that have a very, very awesome perspective on how to mitigate supply chain cyber vulnerabilities. But one thing that's been coming up a lot is product development, cybersecurity. How can we ensure that products are actually secure before they get into the supply chain? Because it probably isn't enough focus on that. And I know it's kind of a DevSecOps type of conversation, but I do think that it needs to be addressed from the more people we talk to. And like Brian Owen from AussieSoft said, it's probably for the sector and the attendees, we have more of a discussion on testing, you know. But I think, you know, there seems to be some certification issues out there with some of the OEMs still. And there's also, you know, a lot of testing for vulnerabilities that isn't taking place in procurement issues. So, you know, those are where a lot of our questions are through the research we're doing. Is like, wow, you know, and
it's reasonable. Yeah. It's perfectly reasonable. What's not reasonable in 2021 is to just fundamentally accept without anything. I said it's good. Go ahead. You can't do that. It's not. The world does not accept that today. There has to be a way to be able to certify. There has to be a way to prove that the product has in fact been certified, is legitimate, and does in fact do what it's supposed to do. Otherwise, you know, it's just, well, Mike said it's okay.
We hear a lot about it.
Say, don't put anything in your plant because Mike said it's okay.
Mm-hmm. Yeah, there's a lot of assumptions as well that if you're purchasing from a large, well-known organization, that everything's hunky-dory, so to speak. You know, and we're hearing different. You know, we're hearing about products that are entering the supply chain that really haven't been tested thoroughly, and some of them potentially aren't certified, and it's a bit shocking that, you know, then we have this whole issue of just are we actually developing products, and it's an entirely different conference actually that I'm thinking about putting together, is, you know, where the chip manufacturers and the chief product security officer